They say space isn't empty. It's just waiting for us to cross it, to test its distance, to find out how far really is. But there's a problem. The space between the stars is so wide that even light takes years to cross it. And light doesn't sleep. We do. So here's the question that keeps scientists awake. What if the only way to explore the galaxy is to sleep through it? That single idea, cryosleep, has moved from science fiction to scientific blueprint. But how close are we, really, to putting humans to sleep for decades and waking them up on another world? And even if we could, what happens to time itself while we're dreaming through the void? Because when you start mixing frozen bodies with relativistic travel, something strange begins to happen. Time stops behaving like we remember. Think about this. If you could press a button and wake up 100 years in the future, would you do it? It sounds peaceful, like skipping the boring parts of history. But what if that 100 years felt like one long breath to you, and to everyone else, it was a century gone? You wouldn't just travel through space. You'd be a ghost in time. That's what cryosleep and time dilation promise and threaten. Two technologies that sound like magic, but are both built on physics, biology, and one uncomfortable truth. Humans were never designed to travel beyond our solar system awake. The real problem starts with scale. Mars is close, 8 months away with current rockets. Neptune, at its farthest, is 4.3 billion kilometers. The nearest star, Proxima Centauri, is 40 trillion kilometers. At the speed of the fastest spacecraft ever built, it would take more than 6,000 years to get there. 6,000 years of food, air, water, and psychological endurance, impossible for any living crew. So scientists looked for shortcuts, not faster rockets, sleeping passengers. The idea is simple on paper. If we can safely slow a person's metabolism by 90 or 95%, their body would need almost no oxygen, almost no food. Their cells would move so slowly that weeks could feel like seconds. You'd be alive, but paused, like pressing sleep on your laptop. Only your laptop is a person. It sounds simple, but behind that simplicity lies the greatest biological gamble humanity has ever imagined. We already see versions of this in nature. Certain frogs freeze solid in winter. Their hearts stop beating. Their blood turns into a kind of biological antifreeze. When spring comes, they thaw, take a breath, and hop away as if nothing happened. Bears, ground squirrels, and some lemurs lower their body temperature, heart rate, and breathing for months at a time. Torpor, scientists call it, the body's power-saving mode. Humans don't naturally do this, but the building blocks are there. Hospitals already cool trauma patients to reduce brain damage. It's called therapeutic hypothermia. When the body's temperature drops, metabolism slows, oxygen demand falls, and the brain can survive longer without blood flow. Doctors use it to buy time. Space engineers wonder if we can stretch that time from hours to years. Here's the tricky part. To keep someone in a cryogenic sleep for years, you need to manage everything the body quietly does for you right now, without your help. The lungs must still move air. The heart must still push blood, even if it's slow. Waste has to leave the body. Muscles, without movement, atrophy. Bones, without gravity, thin out. The longer you sleep, the more you disappear. That's why NASA isn't talking about freezing people solid like in the movies. They're talking about induced torpor, a deep, reversible hibernation. At a lab in Atlanta, researchers have already put animals into torpor using controlled cooling and special drugs that tell the brain to power down. In theory, humans could one day be placed in pods that lower their body temperature to around 10 or 12 degrees Celsius, monitor vital signs, recycle oxygen and carbon dioxide, feed nutrients through IV drips, and gently stimulate muscles with tiny electric pulses to prevent decay. Every few weeks, the pod could warm the person just enough to restore circulation, then cool them again. Like tides of warmth and sleep washing through a frozen sea of bodies. It sounds peaceful, but imagine what that ship would feel like. Rows of people suspended in silence, their breath forming thin halos of frost against the glass. The hum of the life support systems steady as a heartbeat. Outside, nothing but black and the whisper of cosmic dust hitting the hull. Inside, years slide by like minutes. The ship's computers would keep the voyage alive, navigating, adjusting course, checking each sleeper's vital signs. Maybe one caretaker AI stays awake, wandering the ship's corridors in eternal solitude, waiting for a day when it can finally wake the dreamers. If that image feels haunting, that's because it is. Deep space travel isn't just a technical challenge, it's an emotional one. You don't just leave Earth, you leave time. Let's pause on that. Time. Because this is where things get strange. Even if you could sleep through decades, time would still be moving for you, almost as it does for everyone else. But if your ship starts traveling close to the speed of light, Einstein's equations say something different happens. Time slows down. Not in a metaphorical way. Literally. Your heart still beats. Your thoughts still move normally to you. But from the outside, the universe sees you in slow motion. If you travel at 99.9% of light speed, every year you experience on board equals about 22 years back on Earth. Go faster. 99.9999%. And every year for you could equal thousands for those you left behind. To you, the trip might feel short. To the rest of humanity, you're gone into the future. That's time dilation. It's built into the geometry of spacetime itself, a consequence of motion and mass, and it's not something you can turn off. Every atom of your body experiences it. Even light, in its own way, feels no time at all. It leaves a star and arrives at your eye instantly, from its point of view. Combine that with cryosleep, and you have a strange cocktail of physics and biology. Imagine boarding a ship bound for another star. The engines accelerate for months, pushing you close to light speed. Then you sleep. On the ship, only a few years pass. Back on Earth, centuries roll by. You wake to find that the constellations have shifted. The languages you knew are gone. Earth, as you remember it, is history. To everyone else, you were a story that ended long ago. In that sense, cryosleep isn't just about surviving distance. It's about surviving time itself. It's a promise that says, you might not live to see the future, but maybe you can sleep until it arrives. Still, time dilation is both gift and curse. It can make interstellar travel possible, but it also isolates travelers in a one-way bubble. For the people aboard, maybe only 5 years pass. For their families, it's 500. By the time they send a message home, the people they knew are long gone. Every journey becomes an act of surrender to time, as much as to space. That's the part no equation can soften. A perfect cryo chamber might keep your body alive forever, but it can't promise you'll wake into the world you left. It's the loneliest kind of immortality. Still, we can't stop dreaming about it. The human imagination keeps coming back to that image of sleeping through the stars. It's the oldest wish in the cosmos, to travel farther than our lifetime allows. And maybe, one day, cryosleep won't just be a dream. Right now, companies working with NASA are developing torpor systems for long-duration Mars missions. The idea is to keep astronauts asleep for weeks at a time to save food, water, and space. That's step 1. Step 2 is years, not weeks. Beyond that, deep space. We're already testing materials that can withstand decades of radiation. We're designing autonomous medical systems that can operate without human doctors. And on the physics side, scientists keep refining our understanding of relativistic travel. We may not reach light speed anytime soon, but even a fraction of it, say 10%, would turn centuries of flight into decades. Combine that with cryosleep, and a crew could leave Earth in their 30s and wake up at another star still young, their ship having carried them across what to Earth was 100 years. For them, the journey is a nap. For us, it's history. But here's the twist that few people talk about. Keeping humans alive for that long isn't just a biological challenge, it's a psychological one. Our minds evolved to measure time through change, sunrises, seasons, heartbeat rhythms. In a cryosleep pod, all of that is gone. Even if consciousness were paused and restarted, what would that mean for memory? Would you wake up as the same person, or someone new wearing your past like an old coat? The self is built on continuity. Break that. And who are you when you wake? Some neuroscientists suggest that long-term suspended animation could alter how the brain encodes identity. Even brief medical comas can create memory gaps and emotional shifts. Multiply that by decades, and the question becomes chilling. Do sleepers wake as explorers, or as strangers to themselves? And what if something goes wrong mid-journey? No one to wake you. No one to repair the systems while you sleep. That's why future ships will likely keep 1 or 2 crew members awake at a time, rotating through watch cycles. A lonely kind of guardianship. Imagine being that caretaker, walking through silent corridors lined with frozen crewmates, checking readouts, hearing your own footsteps echo. Every hour, a century away from home, keeping the dreamers alive. If that sounds poetic, it's also terrifying. Cryosleep saves energy, but costs humanity moments of connection. It's efficient, but empty. Maybe the real challenge isn't whether we can build the machines, but whether we can bear the silence they create. Let's circle back to where we started. Why even try? Why put people to sleep instead of just sending robots? Because exploration, at its core, isn't about data. It's about presence. A robot can take pictures of an alien sunrise, but it can't see it the way a human can. With awe, with emotion, with meaning. To see something truly new, someone has to be there, breathing that alien air, even if they had to sleep a century to get there. Cryosleep and time dilation are the twin keys that might make that possible. One stretches biology, the other stretches physics. Together, they bend what it means to live a single lifetime. The first time a human leaves Earth knowing they won't wake for decades, it'll mark a new kind of courage. Not the courage to face danger, but to face absence. To close their eyes, trust the machines, and hand their future to time itself. We're not there yet. But each experiment, each prototype chamber, each study of torpor in astronauts brings us closer. When the first sleeper ship finally launches, humanity won't just be traveling through space. It'll be slipping between minutes and centuries, carried by dreams. And maybe, one quiet morning far from home, the first sleeper will open their eyes, step onto a new world, and realize something incredible. For them, the journey took a breath. For the universe, it took forever. Far from any planet or sun, a solitary spacecraft glides through the darkness with scarcely a sound. It is a long, sleek vessel, drifting in the interstellar void between star systems. No radio chatter surrounds it. No nearby beacon marks its passage. Only the distant glow of innumerable stars in every direction. Against that vast backdrop, the ship is a tiny speck of human endeavour, carrying its sleeping crew onward. This is their ark in the emptiness. A metal shell, protecting a seed of life as it moves silently through the cosmic night. From the outside, the ship is mostly dark, conserving power. Occasionally, a manoeuvring thruster flares a brief blue plume as the autopilot makes a minute course correction. But otherwise, the vessel presents a cold and quiet exterior. The hull is coated in protective material and heavy shielding. Over time, it has become pitted with microscopic craters from dust impacts and faintly discoloured by the steady bath of radiation. At the ship's bow, a thick forward shield absorbs or deflects any stray particles encountered at high speed, vaporizing them in quick bursts of heat. Behind that shield, the tapered body of the ship carries the precious cargo of passengers and equipment. Starlight glints off its surfaces now and then, but inside, the travellers see none of it. They remain in darkness and cold, tucked safely within. Within the ship's interior, all is dim and hushed. The Cryosleep chamber lies deep in the heart of the craft, where layers of water tanks, supplies, and specialized alloys encircle it to ward off cosmic radiation. Here, in this protected womb of metal, rows of hibernation pods stand quietly aglow with soft indicator lights. The air is chilled and unmoving, circulated gently by silent fans to ensure each sleeper gets enough oxygen. Thin tendrils of frost have formed on some surfaces, glinting in the low bluish light of the monitors. Floating through the corridor, one would hear almost nothing, perhaps the muted hum of electronics or the faint whoosh of air through vents. The human figures inside the transparent pods lie motionless, faces peaceful and untroubled, illuminated in pale green by readouts displaying their vital signs. They might be mistaken for sculptures were it not for the subtle rise and fall of their chests. Each sleeper is surrounded by a cradle of machinery attending to their needs. IV lines delivering nutrients, tubes carrying away exhaled carbon dioxide, sensors tracking heartbeats and brainwaves. This chamber is like a dormitory in space, except all the beds are occupied by those who will not stir for a very long time. Elsewhere in the ship, many systems have been powered down to a bare minimum. There is no need to light the empty crew quarters or run the unused galley or exercise machines. The command deck, with its chairs and control panels, rests in standby gloom, illuminated only by the blinking of status LEDs. Storage bays full of tools and supplies lie in darkness, sealed up until they are needed upon arrival. The entire vessel feels as though it, too, is slumbering, keeping only its essential organs running. In a sense, the ship is in hibernation alongside its passengers. It cruises on autopilot through the void, maintaining life support and guidance, but postponing any other activities until the proper time. Only then will it awaken fully along with them. Yet the ship is not devoid of vigilance. Its central computer remains ever alert, tirelessly performing system checks and scanning the environment. Life support modules continuously adjust the air mixture, scrub away excess carbon dioxide, and keep temperatures low and stable in the crew habitat. Guidance sensors watch the stars, using their positions as a navigational map to verify the ship's course. Every so often, the autopilot fires a small thruster to fine-tune the trajectory, ensuring the vessel stays on the optimal path toward its distant target. If a piece of interstellar debris were detected ahead, even something as small as a pebble, the ship's systems would spring into action to protect the sleeping crew. Perhaps the forward radar has pinged a stray fragment of rock at some point. If so, the computer would have subtly altered course or orientation, or energized an electromagnetic deflector to nudge charged particles aside. All of this happens in silence, without ceremony, as the ship carries out its solemn duty of care. In the absence of conscious crew, the vessel itself has taken on the role of watchful guardian. Hazards in interstellar space are rare, but not absent. Now and then, a lonely micrometeoroid, no bigger than a grain of sand, may cross the ship's path at tremendous speed. An impact with even a speck could be catastrophic without protection. That is why the ship's architects equipped it with multiple layers of shielding. The outermost layer is a thin sacrificial sheet designed to take the brunt of micrometeoroid hits, vaporizing them on contact. Behind that are thicker plates of composite armor that will crack or disperse any larger projectile that gets through. Additionally, tanks of water lining parts of the hull serve a double purpose. They supply life support and also absorb radiation and particle impacts. When high-energy cosmic rays from distant supernovae streak through space, the water and special plastics soak up much of that radiation before it can penetrate to the crew chamber. The result is that as the ship traverses the emptiness, tiny collisions and flashes of radiation occur harmlessly outside its walls, unnoticed by anyone. Inside, not a single alarm blares, and the sleepers remain undisturbed. The engineers on Earth, though far away, have effectively extended their protection around the crew by these means, ensuring that the journey can continue safely through the unseen hazards of the galaxy. By now, the ship has been flying for years, slipping further and further from everything that was once familiar. Soon after launch, it left behind the outermost planets and drifted beyond the frozen edges of the Oort cloud, where countless comets circle in the deep freeze of space. Beyond that, it bid farewell to the influence of Earth's sun entirely. It crossed the heliopause, the invisible border where the solar wind's dominance ends and interstellar space truly begins. At that moment, the vessel entered a new domain between the stars. The sun, which once loomed large and bright, has dwindled to a particularly luminous point far behind, distinguishable from other stars only by instruments. Earth itself is far too small and distant to be seen anymore. It is nothing now but memory and data. The constellations ahead have subtly shifted as the ship's perspective changes. Stars that were once arranged in familiar patterns now appear in slightly new positions. The vessel is sailing under strange skies that no human eyes have yet observed. The thick band of the Milky Way, full of clustered stars and dark nebula clouds, stretches across space, and the ship moves steadily beneath its arch. There are moments when it passes through the wisps of an ancient supernova remnant, or skims the edge of a tenuous interstellar gas cloud. But mostly it is an expanse of near-perfect vacuum. The nearest bit of matter might be a fragment of dust a few thousand kilometers away. In cosmic terms, that is practically next door. Otherwise, the ship is utterly alone with the starlight. Communication with home has grown ever more tenuous with distance. Radio messages from Earth, once frequent, now arrive only after long delays and faint in strength after travelling trillions upon trillions of kilometers. The ship's computer still listens for them, capturing the periodic status inquiries or well-wishes that mission control beams into the void, and it dutifully sends back its own brief reports. But round-trip communication now takes years. By the time a signal reaches the ship and a response returns to Earth, entire eras may have passed for those on the ground. Eventually, a point comes when the vessel is simply too distant for meaningful back-and-forth conversation. It continues onward, increasingly an island unto itself. Mission Control's console displays that once showed the crew's status have likely been dimmed. The people who launched this mission may have moved on to other projects or even retired, leaving behind successors who wait patiently for any sign from the far-flung travelers. The ship, however, does not mind the silence. It has everything it needs to complete the crossing on its own. Inside, the sleepers know nothing of the broken communications or the emptiness behind them, and so the vessel presses on, self-sufficient and alone, with only the stars for company. All the while, the distance to the destination is shrinking. Unbeknownst to the slumbering crew, the faint point of light that is their target star has been growing ever so slowly brighter ahead of them. Once, it was just another star in the sky, indistinguishable from the rest. Now, after many years of travel, it has gained a subtle prominence. To the ship's optical sensors, the destination sun now outshines the background stars in its vicinity. It has become a beacon guiding the craft forward. Still, it remains a tiny, cold gleam to any hypothetical observer on the ship, providing no appreciable warmth yet. But with each passing day and each billion kilometers traversed, it brightens incrementally. Many months or years of flight still lie ahead, but the fact that the star is perceptibly closer is a silent herald of progress. When the ship is near enough, the onboard systems will detect a stronger gravitational tug and a steady increase in that star's light. Then will begin the slow process of awakening the crew and preparing for arrival. For now, however, that moment is still a distant event. The star grows slowly. The long night endures a while more. One day, in the not-too-distant future, the sleeping voyagers will awaken to see a new sun filling their sky. The quiet ship will come alive with human voices and activity once more. Until then, this craft remains a cosmic dormitory, carrying its occupants in peaceful inactivity across a span of light years. Many more lonely miles must be crossed before that dawn arrives. This is deep space travel as it truly is. Not the frenetic adventure of rocket fire and zooming spacecraft from old science fiction. Instead, it is a patient, grace-filled passage through solitude and darkness, with technology and nature in delicate balance. The beds between the stars remain occupied by their dreamless crew. The ship carries them faithfully forward, ever closer to the dawn that will one day end their long sleep. In the silent expanse between stars, time itself seems to hold its breath. Out here, on our deep space voyage, beyond the familiar cycles of day and night, we begin to sense that time has more than one face. In our everyday lives, time marches on steadily, each second following the next in perfect rhythm. But in the depths of space, under the strange conditions of high speed and isolation, time reveals another side, subtler, malleable, and not quite as uniform as we once believed. Our previous chapter explored the idea of cryosleep, placing voyagers in a state of suspended animation to help them endure lengthy voyages without experiencing each passing moment. Cryosleep can slow the aging of the body and mind from the traveler's perspective, allowing them to sleep through decades. However, while it may soften the subjective burden of time, cryosleep does not alter the march of time itself in the outside universe. Even as the crew sleep soundly in their pods, the years still unfold in the wider cosmos. When they wake, they could find that the universe around them has changed dramatically, simply because of how much objective time has elapsed. This realization leads us to ponder the second great factor in deep space journeys, the pliability of time itself under the laws of physics. We usually think of time as absolute, a single, universal clock, ticking the same for everyone. A moment is a moment, whether on Earth or on a distant planet, or so it seems at first glance. We live by the regular cadence of clocks and calendars, confident that an hour for one person is an hour for anyone else. This comfortable intuition is woven into how we experience life. A minute feels like a minute, a year. Yet the universe has a gentle way of showing us that this is only part of the story. Imagine two identical clocks, one resting in your home and the other taking a journey on a fast-moving spaceship. At the outset, they tick in unison, matching second for second. But as the spaceship ventures farther and accelerates to incredible speeds, something almost magical happens. The travelling clock ticks ever so slightly slower relative to the one left behind. Days on board might correspond to more days back home. The difference at first is minuscule, far too tiny for human senses to notice. But it's there. A creeping lag, a subtle shift in the flow of time. This phenomenon isn't science fiction or just a fanciful thought. It's a real effect called time dilation, built into the fabric of our universe. With each increase in speed, with each deeper plunge into the cosmic expanse, the moving clock's time keeps gently stretching. To the traveller on the ship, nothing feels different. Their heart still beats normally. Their internal sense of time remains steady. But when they compare clocks with someone back on Earth, they discover that their journey has carried them not just through space, but also a little bit into the future, relative to home. Through this lens, time shows two faces. One face is familiar, the steady tick-tock we know and trust. The other face emerges under extreme conditions. Clocks running at different rhythms, depending on motion and gravity. It is as if time can slow its pace when we voyage among the stars, allowing a fast traveller to move ahead into the future more quickly than those who stay behind. This dual nature of time is subtle and mysterious, yet it has been confirmed by precise experiments and the journeys of astronauts themselves. On Earth, living our daily routines, we rarely notice this hidden aspect of time. It's masked by the slowness of our everyday motions. But as our ship cuts through the darkness at a significant fraction of light speed, the difference begins to grow. The universe whispers its secret, that time is not rigid after all. It can stretch and shrink, showing one face to the traveller and another to the one who remains still. Such a realization invites us to rethink what a moment truly means. We carry an innate sense that time is universal, yet our deep space trek reminds us that time can flow differently, depending on the path we take. In the calm and quiet of our vessel, we start to feel the outline of this truth. Clocks in different places, moving in different ways, do not agree perfectly. They each follow their own rhythm, and so, as we drift further from home, we embrace the idea that our journey is as much through time as it is through space. Gently and inevitably, the concept of time begins to expand in our minds. We picture it now, not as a single river flowing at one steady speed, but as a collection of streams that can trickle or rush faster, depending on the terrain. In daily life, all those streams run nearly parallel, giving the illusion of one uniform current. But out here, voyaging swiftly through the cosmos, our stream diverges just enough for us to notice a change. The clocks remind us of this divergence, if we care to look closely. One face of time gazing back at Earth, and one looking ahead to the stars with us, each keeping its own counsel. As we come to accept these two faces of time, a gentle curiosity takes hold. How exactly does motion slow the ticking of a clock? Why should a spacecraft's rapid journey alter the flow of time it experiences? To explore that, we delve into the quiet, elegant principles that govern time and speed. The answers lie not in clanging gears or mechanical tricks, but in the very nature of light and the universe's fundamental rules, a soft mathematics of motion that we will now unfold. We begin to unpack the reason behind time's flexibility. The secret lies in the speed of light. In the early 20th century, scientists like Albert Einstein discovered a startling truth. No matter how fast you move, light's speed remains the same for everyone. This constancy is like an anchor in the universe. If you race toward a beam of light or away from it, you still measure that beam rushing by at the very same cosmic speed. Such a rule sounds simple, yet it carries profound consequences. To preserve this universal speed limit, something else must give, and that something is time and space themselves. Imagine a simple clock on our spaceship, a beam of light bouncing between two mirrors, ticking off time with each bounce. When our ship is parked at rest, the light travels straight up and down between the mirrors, and we count a steady beat of ticks. Now imagine the ship starts moving very fast. To us on board, nothing seems different. The light still goes up and down, and our clock ticks normally. But picture what an observer back on Earth would see. As the ship moves forward, the light beam now traces a zigzag path, travelling a little diagonally to catch the moving mirror. Each tick of the clock for the Earth observer takes a longer path than before. And since light cannot speed up, it's always going the same speed. Those ticks must take more time from that outside perspective. The Earth observer concludes that our moving light clock is running slow. For the observer back on Earth, it's as if our moving clock has slowed down. Each tick lags a little behind what it would be if the clock was still. This isn't an illusion or a mechanical fault at all. It is a genuine shift in the flow of time caused by motion. Through this demonstration, we catch our first glimpse of how a fast journey can stretch the seconds and minutes of time. In essence, this thought experiment reveals why a fast-moving clock ticks slower than a stationary one. It's not that the clock is broken or being affected by mechanics. It's a result of geometry and space-time. Time and space adjust so that everyone, on the ship or back home, sees light obey the same speed limit. For us on the ship, time flows normally, but from Earth's viewpoint, our time has stretched just enough to make the physics work out. The equations that emerge from this idea form the soft mathematics of speed, elegantly describing how much time bends with motion. Scientists summarize this effect with a factor that grows as you approach light speed. At everyday speeds, this factor is nearly 1, making time dilation imperceptible. But at truly high speeds, the factor swells. For instance, if we could travel at about 87% of light speed, our ship's clocks might slow to half the rate of Earth's. A day aboard would correspond to 2 days passing for those at home. Push closer to 99% of light speed, and the effect is even more dramatic. Time aboard might run only about 1/7 as fast compared to Earth. That means on a long voyage near light speed, the crew might experience only a few years while back on Earth. Decades slip by. These numbers paint a remarkable picture. Speed turns out to be a kind of gentler thief of time, stealing away hours and years from the perspective of those left behind. Yet to the travellers themselves, nothing is taken at all. Their lives play out normally, just over far fewer Earth chronicles. It is a strange bargain written into the universe. The faster you move through space, the slower you move through time from others' point of view. It's as if moving fast lets you trade some distance for time, cruising swiftly through space, but also forward in time relative to those slower paced. Crucially, nothing with mass can reach or exceed the speed of light, so we can never freeze time completely or go backward. If we tried to go faster and faster, we would approach an extreme. Reaching ever nearer to light speed would make the time dilation factor grow without bound. If, in a fanciful imagination, we could ride a ray of light itself, time would stand still, entirely in our frame. That is an unreachable dream, always out of grasp, because the laws of physics prevent anything with mass from attaining that ultimate speed. But considering it highlights just how powerful the effect is as we get close to the cosmic speed limit. Understanding this interplay of speed and time gives us a profound tool for planning deep space journeys. If future technology allows humans to travel at a significant fraction of light speed, we know their voyages could compress subjective time dramatically. A journey that looks impossibly long in the calendars of those on Earth might be quite reasonable for the crew in terms of their own aging and experience. This soft mathematics, captured in Einstein's theory of special relativity, provides more than equations. It offers an almost poetic insight. It tells us that moving swiftly through the void alters the rhythm of our existence. As we absorb this knowledge aboard our imaginary ship, we feel both wonder and solemnity. The universe permits a form of one-way time travel into the future. By venturing fast enough, travelers can effectively leap forward in time relative to their origin. All it requires is obeying the cosmic speed limit and letting time's pace adjust accordingly. With this understanding, we carry on through the darkness, aware now that every increment of velocity subtly changes our relation to time. And while speed can stretch time, it is not the only influence at work. There is another quiet player in this game, the presence of gravity itself. Even in the stillness of a sleeping ship, or on the solid ground of a planet, gravity bends the flow of time in its own gentle way. Our next realization on this voyage is that time also has weight, and gravity's soft grip can slow the ticking of clocks just as surely as speed can. Gravity, too, quietly alters the flow of time. We all live within Earth's gentle gravitational pull, and it turns out that even here, time is ever so slightly stretched by gravity's presence. Down at sea level, closer to the bulk of Earth's mass, clocks tick just a touch slower than they would on a mountaintop high above. The difference is tiny, almost impossible to notice without sensitive instruments, yet it is very real. Scientists have tested this by comparing ultra-precise clocks at different altitudes. A clock on a mountain runs a fraction of a second faster over many years than one at the bottom of a deep valley. Gravity's grip, albeit quiet and weak in our daily lives, still leaves its mark on time's passage. In stronger gravity, the effect becomes more pronounced. Imagine an astronaut floating far from any planet, and another astronaut standing on a massive world or near a dense star. The one in the stronger gravitational field ages more slowly relative to the one in open space. Every heartbeat for the person deep in gravity's well takes slightly longer as seen from the outside. They themselves feel time normally, unaware of anything unusual. But if our two astronauts could compare clocks after some time, the one who had been closer to the heavy mass would have experienced fewer ticks of the clock. In essence, being in a region of stronger gravity is like moving in slow motion through time compared to someone in a weaker gravitational field. This isn't just speculation. It's a consequence of how gravity warps the fabric of spacetime. Einstein's theory of general relativity revealed that mass doesn't just attract other mass, it also stretches and slows time. Even light feels this effect. When light climbs out of a gravitational well, it loses a bit of energy, like a traveler hiking uphill. Time itself is part of that climb. To a distant observer, processes in a strong gravitational field seem to run sluggishly. A clock, a heartbeat, or a pendulum near a massive object will all appear to tick more slowly when observed from far away. This is gravity's quiet influence on time, pervasive yet only noticeable under extreme conditions or with meticulous measurement. Gravity's effect on time, though subtle on everyday scales, accumulates over long periods. Deep within the Earth, for instance, time runs slightly slower than at the surface because of the stronger gravity. Over billions of years, this adds up. Physicists have estimated that Earth's core is actually a few years younger than the crust, simply because the core has spent eons in a more intense gravitational field that gently retards its passage of time. It's a mind-bending thought. The very rocks beneath our feet experience time just a touch differently than the rocks on a mountaintop. But it underscores how pervasive and real gravity's time warping is. For an extreme illustration, consider a spacecraft daring to venture near a black hole, one of the most massive and compact objects in existence. A black hole's gravity is so intense that it dramatically slows time in its vicinity. If our ship were to skim close to such a dark giant, without falling in our careful thought experiment, time aboard the ship would crawl compared to time far away. Perhaps a few hours spent near the black hole might correspond to years passing in the outside universe. The crew orbiting that abyss would find that while they orbited in relative calm, distant stars evolved, and calendars in the wider universe flipped forward at a blistering pace. They would emerge having hardly aged, while outside worlds had moved on through ages. We need not go so far as a black hole to see gravity's effect on a voyage. Even a journey that swings by a massive planet or a dense star could introduce noticeable time shifts. If our deep space travelers plotted a course taking them near Jupiter or skimming the gravity well of a neutron star, their onboard time would be altered by that encounter. It might be slight or significant, depending on the mass involved and how close they come. But the principle is the same. Gravity slows their clocks relative to an outside frame. A careful mission log would later reveal that those hours spent in the embrace of a massive planet were a bit longer than hours measured on Earth. All these considerations, both the high-speed travel and the pull of gravity, show us that time is not the immutable backdrop we once assumed. Instead, time can stretch and shrink differently for different journeys. If one person stays on Earth, while another undertakes a bold voyage, looping near massive bodies and reaching relativistic speeds, their experiences of duration will diverge. This naturally brings to mind a poignant scenario. Two twins, one who ventures among the stars, and another who remains at home. How differently will time treat them? Gently now, we turn to that story, known famously as the twin paradox, to see these ideas come to life in a human tale of separation and reunion across the years. Imagine two twins, born on the same day, and as alike as two lives could be. They grow up together with the same spark in their eyes and the same measure of time guiding their days. One of these twins, filled with a quiet, adventurous spirit, decides to embark on a long journey to the stars. The other twin chooses to remain on Earth, tending to the familiar comforts of home. With tender farewells, they part, not knowing how differently the river of time will flow for each of them until they meet again. The travelling twin boards a sleek interstellar craft, bound for a distant star system. As the engines ignite, the ship accelerates away from Earth, and the journey through space-time truly begins. The initial moments are intense. The twin feels a deep pressure as the craft gains speed, vibrations humming through the hull. Then, gradually, the sensation smooths out as the ship reaches its cruising velocity, a significant fraction of the speed of light. Out the window, stars stretch into faint streaks of light. In those quiet moments, the twin might press a hand to the glass and think of the sibling left on Earth. Do they see the same stars tonight? The vast distance and the slow ticking of the ship's clock make such thoughts both comforting and haunting. With no day-night cycle except the one maintained on board, time becomes more abstract, marked mainly by the ship's instruments and the traveller's own heartbeat. During lonely nights on the ship, the twin floats by the observation window, watching an endless night spangled with stars. Some shine with fierce brightness nearby, while others are distant, delicate pinpricks of light, their glow having travelled eons to reach the ship. The pale band of the Milky Way sweeps across the darkness, a constant reminder of home far behind. It is a breathtaking and humbling sight, a galaxy's tapestry laid out before the eyes of a solitary traveller. Meanwhile, the other twin watches the sky from Earth and marks the passing seasons. Letters and transmissions from the spaceship arrive, but very infrequently, separated by long gaps of silence due to the immense distance. The Earth-bound twin celebrates birthdays, gathers years, and sees the world change gradually around them. They hold on to memories of their sibling, who is now far away, racing through the cosmos. The wait is long and filled with a mix of pride and longing. Looking up on clear nights, the twin left behind wonders how their other half is faring out there and when, or if, they will return. The traveller eventually reaches the turning point near a distant star. The spacecraft swings around, firing thrusters to decelerate and reverse course for the journey home. This reversal is another intense chapter, a burst of acceleration and strain as the twin on board feels gravity-like forces while the ship slows and pivots. Then the homeward leg commences, another extended period of calm, cruising through deep space. All the while, the clocks on the ship have been ticking at their leisurely, relativistic pace. For the traveller, the entire mission, out and back, might register as, say, 10 years of life. They have grown older, yes, but only by those 10 subjective years, filled with solitary stars and quiet reflection. When the day finally comes that the starship returns to Earth, it descends through the atmosphere and lands gently on familiar ground. The twins reunite at last, but time has woven a different story for each. The twin who stayed on Earth has lived perhaps decades since the departure. Their hair is touched with grey, their face lined with the experiences of a long span of years. In contrast, stepping out of the spacecraft is a person who looks much younger. The travelling twin appears to have aged only slightly, still in the prime of life, while their sibling has grown old. They embrace the difference in their ages, now a living testament to the journey. Imagine the moment. One twin, eyes brimming with tears of joy, looking into the face of a brother or sister who left as a youth and returned while they themselves became elderly. For the travelling twin, it is as though they have leapt into their sibling's future. The streets of their hometown have changed. Familiar people have grown older or moved on, and history has advanced by a longer measure than they personally experienced. For the twin who remained, the reunion is equally profound. They have memories stretching across a lifetime of waiting, whereas for the voyager, the separation was brief and surreal, as if a short dream had delivered them to a distant tomorrow. This scenario, often called the twin paradox, isn't a paradox at all. It's a real implication of relativistic travel. The symmetry of their situations was broken by the traveller's journey through space, especially the acceleration and deceleration during departure and return. Those maneuvers, threading through the fabric of space-time, allowed the travelling twin to take a shorter path through time. When they come together again, the difference in age is striking, but expected by the laws of physics. What was a long, wistful wait for one was a short odyssey for the other. Their story is a human face on the otherwise abstract concept of time dilation. It reminds us that these effects are not just numbers in an equation, but experiences that people could one day live through. In the quiet of their reunion, the twins come to understand the true cost and wonder of interstellar exploration. To venture among the stars is to step outside the synchrony of ordinary life. Yet, despite the years gained and lost, their bond endures. They share stories, one of decades of life on Earth, the other of a swift cosmic voyage. Each twin, in that moment, grasps how flexible and personal time can be. As we leave the twins in their long-awaited embrace, we turn our eyes back to the spacecraft and its journey. Through the long years of separation, how were the twins able to stay in touch at all? What of the clocks on board that ship, the signals sent across light years, and the challenge of keeping time aligned between a fast-moving vessel and the Earth left behind? To explore that, we step back inside the ship to examine how timekeeping and communication unfolded during the voyage. In the silent halls of the starship, clocks and calendars quietly did their work. And now their story continues with the science of keeping time across the void. Aboard the fast-moving ship, timekeeping becomes an exercise in careful planning and understanding. The clocks in the hull tick away steadily, keeping the crew's daily schedule, but those clocks do not march in lockstep with clocks back on Earth. From Earth's perspective, the ship's time is running slow. A meeting arranged for noon ship time might find that on Earth, the hour has long passed. To the travelers, everything on board feels normal, yet they must recognize that their now is not the same as Earth's now. Thus, the crew and mission planners adopt a pragmatic approach. They treat time as something local to each frame. The ship operates on its own timeline, let's call it ship time, while Earth follows Earth time, and everyone knows these won't perfectly align until the voyage is complete. Throughout the journey, synchronizing events between ship and Earth is a delicate task. Imagine the crew wants to send a progress update every 6 months by their onboard calendar. By the time one of those messages reaches Earth, more than 6 months of Earth time will likely have passed. The farther the ship travels and the faster it moves, the more pronounced this gap becomes. Conversely, suppose Mission Control on Earth schedules a check-in every year by Earth's clock. The crew might experience those check-ins coming at a slower interval according to their own clock. Planning must account for these differences. A year for the ship could be quite different from a year on Earth during the high-speed transit. Then there's the issue of distance and the speed of light, an ultimate governor for communication. As the ship ventures light years away, even a simple greeting or data transmission can take years to arrive one way, regardless of any relativistic time dilation. Messages are not just delayed, they can also be subject to frequency shifts. If the ship is moving away from Earth when it sends a signal, the Earth might receive that signal stretched out in time and shifted to lower frequencies, a kind of cosmic slow motion called redshift. If the ship is on the return leg, flying back towards Earth, its signals arrive more rapidly and compressed, a blue-shifted rush of communication. To handle this, communication systems on both sides are designed to adjust for these effects, ensuring that data is properly received and that the timing of events can be reconciled once the signals are in hand. From the crew's perspective, the communication delays can be poignant. They might gather around a receiver to hear or read the latest bulletin from Earth, only to realize that the news is already years old by the time it reaches them. It's a strange reality. On board the ship, they may celebrate a milestone or respond to a piece of news, fully aware that on Earth, those events have already become part of history. Likewise, any message the crew sends, a holiday greeting, or a simple, "we're doing fine," enters a time tunnel of sorts. By the time their family or colleagues receive it, the calendar back home has advanced far beyond the moment the words were spoken. Interstellar correspondence requires patience. Every exchange is separated by gulfs of time as well as space. The crew and those on Earth must accept that conversations stretch out over years, with long silences in between, and cherish each eagerly awaited response whenever it arrives. Inside the vessel, the crew likely lives by a steady routine, perhaps a 24-hour cycle maintained for health and sanity, and they log events with timestamps according to their ship's chronometer. Those logs later have to be translated into Earth time for debriefing and record keeping. For instance, if an astronaut notes that a certain experiment was conducted on day 100 of ship time, mission control will interpret when that was in Earth's timeline using relativistic calculations. Navigators and scientists create formulas to convert between the time experienced on the ship and the time observed on Earth. It's a bit like converting between languages. Neither clock is wrong, they're just in different frames. Throughout the voyage, the ship's crew and Earth operate under an understanding that each will measure time in their own frame and only truly synchronize after the mission is over. Until then, they must predict and adjust using relativity as a guide so that crucial operations go as intended. If a maneuver needs to happen on a certain date by Earth's calendar, the crew is briefed on what their ship clocks will read at that moment. If a message is sent on a particular ship day, Earth's receivers know when to expect it, even if that date is years in the future. Despite these challenges, communication does endure across the void, and timekeeping remains robust in each frame. The key is understanding and planning for the relativity at play. In a sense, the crew carries two timelines with them: their own lived time and an awareness of Earth's distant timeline. This dual awareness becomes part of the fabric of long-distance space travel. It allows astronauts to say, "According to our clocks, we've been out here 3 years, but we know back home perhaps 5 years have gone by," and to act accordingly. The clocks within the hull continue their soft ticking, guiding life on the ship, all while the travelers hurtle onward. And as they chart their course through space-time, those moving clocks trace out worldlines, threads of history in the tapestry of the universe that we can map and predict, which leads us to the idea of drawing such journeys as paths in space-time itself. To truly understand the traveller's time, one can draw a map not just of space, but of time. Imagine a graph with one axis representing time and another representing distance. An object at rest, like our earthbound twin, would appear as a line that runs almost straight upward along the time axis, staying nearly in the same place in space. A moving object, like the travelling twin's ship, will have a world line that angles away from the time axis, reflecting its motion through space over time. On such a space-time chart, the ship's path might slant outwards and then curve back, showing the outbound journey and the return journey through both space and time. The Earth twin's line and the ship twin's line start together at the moment of departure, diverge during the voyage, and converge again upon reunion. Each point on these lines corresponds to an event, a specific place at a specific time for that twin. By comparing the lengths of these world lines in terms of time experienced, we can understand the difference in aging. The path through space-time taken by the travelling twin covers more distance in space, but ends up accumulating less time than the Earth twin's path. The stay-at-home twin's world line is almost a straight shot through time, so it records the full duration of the journey as measured on Earth. The travelling twin's world line, however, involves high speeds and perhaps a swing near a massive object, and thus it accrues less elapsed time. The proper time along that world line is smaller. Proper time is what we call the time measured by a clock moving along a given world line, essentially the time experienced by someone on that path. For the travelling twin, the proper time of their trip might be 10 years, whereas the Earth twin's proper time over the same interval from the start to finish of the journey could be, say, 40 years. The space-time diagram shows why this difference occurs without any paradox. The twin in the spaceship took a different route through space-time. In the geometry of space-time, the straight path, staying on Earth, maximizes the proper time, while the bent path, speeding away and back, results in a shorter, proper time. Both twins moved forward in time, but one's journey was shorter in time because of the path choices through the cosmos. Visualizing world lines also helps us consider more complex scenarios. If our traveler had taken a detour past a massive planet or performed multiple accelerations and decelerations, those maneuvers would show up as bends or kinks in the world line. Each twist or turn, representing a change in velocity or a swing by a gravitating body, would contribute to reducing the traveler's total proper time relative to a simpler, straighter path. The world line captures it all. Every drift through space, every engine burn, every gravitational assist. It's like having the entire story of the journey drawn out in front of you, making clear at a glance who ages, how much and why. In a sense, our lives can all be thought of as world lines weaving through space-time. We each carry our own proper time, measured by the beating of our hearts or the ticking of our personal clocks. Most of the time, for people living at everyday speeds and in similar gravity, our world lines run almost parallel, and our proper times accumulate nearly equally. But when someone's path diverges, through high-speed travel or venturing deep into gravitational wells, their world line threads a different course through the fabric of reality, one that can leave them out of sync with others upon reconvergence. This perspective turns time dilation from an abstract idea into something almost tangible, a line on a map of time and space. It reassures us that there is no mystery or contradiction. Every traveller's clock faithfully records the passage of time along their own world line. By mapping those world lines, we see precisely how journeys unfold and intersect. With such understanding, we can imagine designing voyages and predicting how much crew members would age and how much Earth would advance in their absence. This way of thinking about time can feel philosophical as well as scientific. In the space-time view, an entire lifespan is like a line drawn from start to finish. Some have wondered if this means the past and future, in some sense, already exist on the map, as if an observer outside of time could see an individual's whole story laid out. Einstein himself, after formulating relativity, hinted at this profound idea, that the distinction between past, present, and future might be more illusion than reality. It's a mind-expanding notion, one that takes time dilation from a physical effect to a new way of conceiving our lives in the universe's grand design. Now, equipped with the ability to chart time as well as space, we venture into envisioning some concrete missions. We will drift outward to distant stars and then return, calculating how many years tick by on board versus back on Earth. In these scenarios, years in space may correspond to decades on Earth, and our maps of moving time will guide us through each step of those profound journeys. Let us contemplate a concrete mission to see time dilation in action. Imagine a spaceship journey to a star system 20 light-years from Earth and back. The plan is to cruise at an incredible 90% of light speed after an initial acceleration phase. From the perspective of people on Earth, the voyage to the star and the return trip together would take roughly 44 years, since even at 0.9 C, covering 20 light-years each way requires time. But aboard the ship, time would flow more slowly. Calculations using relativity tell us that at 0.9 C, the time experienced on the ship would be less than half of what Earth clocks record. For the crew, only about 20 years might pass from departure to homecoming. In other words, if they left in the year 2100, Earth would see them return in 2144, whereas on the ship, it might feel like the year 2120. We can push the scenario further. Suppose the spacecraft could reach 99% of the speed of light. Now the time dilation effect is far more pronounced. At 99% c, gamma, the time dilation factor, is around 7. If that same journey to a star and back was undertaken at this speed, Earth would still count about 40 years in transit. But the travellers would experience only around 6 or 7 years of life on board. Imagine launching in 2100 and coming back to Earth in the 2140s. Yet the crew would have felt as if it were merely 2106 or so. They would step out, having aged only a handful of years, while 4 decades slipped by on Earth. These examples show how a fast journey can vault explorers into Earth's future. The faster the ship goes, the more extreme the discrepancy. A round trip to the galactic neighborhood could make the astronauts essentially time travelers to what for them is a future society back home. For instance, a relativistic expedition that lasts 10 years for the crew might find a century or more has passed on Earth if their speed was extraordinarily close to light. It is both wondrous and poignant. The ship's calendars might mark only a decade of birthdays, while back on Earth, entire generations are born, grow old, and perhaps pass on. This situation, astronauts leaping ahead in time relative to Earth, has long been a favorite subject of science fiction. Stories and films have imagined explorers who return to find their world drastically changed or advanced, grappling with the realization that they have effectively traveled into the future. What once was speculative fantasy, we now recognize as a real physical possibility. Time dilation, not a mystical time machine, is the mechanism that can propel someone into the future faster than those left behind. Knowing this gives an uncanny sense that our science fiction dreams of time travel were hinting at a truth of the universe all along. It's important to note that these dramatic scenarios assume technologies and speeds far beyond what we currently possess. Our fastest probes today travel at mere thousandths of the speed of light. Reaching 90% or 99% of light speed would require breakthroughs in propulsion and energy. Yet, the thought experiments are valuable because they illuminate the ultimate physical limits and possibilities. If one day humanity does build starships capable of such velocities, we know what will happen to time aboard versus time at home. The equations of relativity serve as our guide, ensuring there will be no surprises about the age of our spacefarers upon return. With our worldline maps and calculations, mission planners of the future could plot out voyages with clear expectations. Suppose a crew sets off to explore a promising exoplanet and plans to return. Everyone involved would understand the temporal cost. They might say, "This will be a 5-year mission for the crew, but 30 years will go by on Earth." Such understanding lets them prepare accordingly, emotionally and practically, for the gap that will open between the astronauts and those who remain behind. Picture the day that spaceship returns to Earth after its long drift and loop through the stars. Crowds gather to welcome the crew. For the astronauts stepping off the vessel, perhaps only a few years of personal time have passed since they said goodbye. Yet, they look out and see a world that has moved on by decades. Faces in the crowd may include children, all grown up, or grandchildren they had never met. Buildings and technologies may have advanced. The voyagers have effectively jumped ahead in time, arriving in their own future. They are home, but home is not exactly as they left it. Such is the reality of relativistic travel. The physics that allow us to traverse immense distances also carry us unevenly through time. As our crew members reunite with family and friends, the joyful celebration may be tinged with a strange realization. The travelers remain young relative to their peers. They have beaten time in one sense, experiencing far less of it. But now, they must reckon with what that means on a human level. In the final part of our journey, we will quietly explore those human implications. The memory of a younger voyager returning to an older world, and how hearts and minds adapt to time's peculiar gifts and burdens. The homecoming of a time-dilated traveller is a moment of bittersweet wonder. Consider an astronaut who left friends and family behind for what felt like only a short journey. Upon stepping off the starship, they find those same loved ones altered by many more years than the traveller experienced. A mother they hugged goodbye is now much older. Her hair turned silver in the interim. A little child they once bounced on their knee might now be an adult waiting with a mixture of joy and tears. To the voyager, it feels as though only a brief chapter has passed since those farewells. Yet here they are returning to a scene that has moved on without them. For the traveller, there is a disorienting sense of having skipped ahead in time. Their memories of home are still fresh. Memories of laughter around a dinner table, of streets and towns as they were. But now many of those memories have become just that, the past. The world they knew exists only in recollection. In its place stands a new present that they must come to know. Technology may have advanced, cities may look different, and societal norms might have shifted. The voyager remains essentially the person who departed, still young in body and mind, carrying the perspective of the earlier era they left. Meanwhile, everyone else has marched on through the years, accumulating experiences the voyager did not share. There can be a profound loneliness in that realization. Friends their own age, at least those they remember as peers, might now be decades older or even gone. The community they return to might treat them with fascination and celebration. After all, they accomplished a heroic journey and literally came back from the stars. But who truly can relate to what they've been through? In moments of quiet, the traveller may wander familiar streets that now feel unfamiliar, grappling with the knowledge that they are out of step with time. It's akin to time travel stories of fiction, except this is not fantasy. It is the very real outcome of relativistic flight. On the other side, the loved ones who stayed behind have their own emotional journey. They have lived through the long years of separation, perhaps receiving only the occasional light-speed delayed message from the ship. They have felt the absence, celebrated milestones in the traveller's absence, and adapted to life without them. When reunion finally comes, it's joyous, but also delicate. The elder parent sees a child return, looking hardly older than the day they left. Siblings and friends reunite, trying to bridge the gulf of years with stories and photographs. There is joy that the long-lost voyager is back, mingled with sorrow for the time apart that can never be regained. For the spacefarers, one source of comfort is that they aren't facing this new world alone. Their fellow crew members have travelled the same temporal path. Together, they form a small circle of people who all remember the old days from before the mission. To them, the elapsed decades are a shared blink of an eye. This camaraderie becomes a refuge as they adjust. They swap stories of onboard life and old Earth memories, reinforcing a sense of belonging with each other that helps ease the transition. In a way, their crew is like a little piece of the past that arrived intact in the future, and within that bond, they find understanding that those around them on Earth, however welcoming, might not fully grasp. Yet human beings are nothing if not adaptable. In time, the disorientation can give way to a new equilibrium. The traveller begins to learn about all that transpired while they were away, catching up on years of history, meeting new family members born in their absence, visiting the resting places of those who may have passed on. They carry the legacy of their voyage, a reminder of what humanity can achieve. and this can inspire others. Around them, people might view the returned astronaut as someone almost from the past and future at once, a living bridge between eras, and slowly, the emotional distance can be crossed with understanding and love. After all, though the traveller's clock ran differently, the bonds of affection persist, and they find ways to reconnect. In this way, the tale of the younger voyager is both marvelous and poignant. It shows that venturing into the cosmos has personal consequences that science can predict, but the heart must actually absorb. Time dilation gave the gift of a slower aging to the traveller, but at the price of missing years back home. This trade-off would be weighed carefully by anyone considering such a journey. Some might accept it for the sake of exploration and discovery. Others might find it too heavy a burden. There is no right or wrong choice, only a deeply human one, made in the context of one's life and loved ones. In the broader story of deep space exploration, both cryosleep and time dilation impart a profound lesson. Time is as vital a dimension of the journey as space itself. These twin strategies, one by slowing our body's processes, the other by riding the extremes of physics, offer pathways to bridge the light years. Yet each comes with its human costs and considerations. As we look ahead to the possibility of venturing ever farther, we carry with us the understanding that such voyages will test not just our technology, but our hearts and resilience as well. And however strange the flow of time may become out there, it is our emotional connections and our enduring curiosity that will light the way, linking the travellers and those who await their return across the gulf of years. For a moment, the starship drifts in silence after departing the warmth of its home world. In the gentle darkness between planets, its engines begin to stir, starting their long duty of carrying life across the stars. Unlike the explosive launch that broke the vessel free of Earth's gravity, this new propulsion builds quietly. There is no loud roar in the vacuum of space, only a faint vibration through the hull as power flows into the drive. The crew, already tucked into dreamless cryosleep, do not witness the ignition. They sleep through this milestone, cradled in silence as the journey truly begins. In ages past, chemical rockets provided the first stepping stones beyond Earth. Those engines were ferocious and fleeting, vast flares of fire and thunder that lifted astronauts skyward for minutes before falling quiet. A chemical engine gulps propellant and burns hot, but its energy is spent almost as soon as it starts. In the quest to cross interstellar distances, such brief fury is not enough. The distances are too great, and the required speeds too high for any chemical flame to carry a ship so far. Yet those early rockets opened the way, and even this interstellar ship still carries echoes of that era. Perhaps solid fuel boosters or chemical thrusters aided its departure from Earth's orbit with a final flash of light. Once that initial push is done, however, the task of stretching out into the cosmic night falls to more enduring power. Deep space demands engines that can burn, not for mere minutes, but for years on end. The starship transitions to a different kind of drive, one born from the unleashed power of the atom. In the quiet emptiness beyond the last planets, a nuclear engine engages. Unlike the raging fire of a chemical rocket, this engine's heart glows with a steady heat. Perhaps it is a nuclear thermal rocket, heating gas with a reactor's core and letting it rush out to produce thrust. Or it might be something even bolder, a series of atomic pulses, small nuclear charges released behind the ship, each one a controlled staccato push forward. These nuclear propulsions lack the bright flame of chemical rockets. Their power is more invisible, a heat that makes reaction mass expand, or a shockwave that gently nudges the ship faster. The hull may softly rattle with each distant pulse, a far-off percussion felt as a faint tremor by the sleeping passengers. Through nuclear fire, steadily and relentlessly, the ship gains speed, pushing further into the night. Even the atom's energy might not be enough to bridge the vast gulf between stars swiftly, so engineers have looked to the stars themselves for inspiration. In the engine room of possibility lies a fusion drive, the kind that mimics the very reactions powering our sun. One can imagine capsules of hydrogen isotopes merging under intense pressure in bursts of artificial starlight. When these atoms fuse, they release tremendous energy, far greater than any chemical explosion and more continuous than a fission-based pulse. The spacecraft carries within it, in theory, a tiny star of its own making. Each fusion pulse or steady fusion burn glows fiercely in confinement, the energy directed out the back as thrust. To human eyes, if one were watching from afar, there might be only a pale, ghostly exhaust, a blue-white torch burning in vacuum, faint but persistent. The crew remain in their suspended slumber, unaware of the star's power harnessed on their behalf. All they might feel, if they could feel, would be a gentle, sustained push as the ship steadily accelerates, year after year, driven by this artificial sun captured in a machine. Beyond fusion lies an even more exotic fire: antimatter. In the realm of speculation and cutting-edge science, antimatter represents the ultimate fuel. When a particle of matter meets its antimatter counterpart, they annihilate each other completely, transforming every bit of their mass into pure energy. It is a conversion so total and powerful that just a few grams of antimatter reacting with matter could outshine the mightiest chemical rocket by orders of magnitude. In the hush of deep space, an antimatter engine might not look dramatic. Perhaps just a faint illumination in a magnetic chamber, as matter and antimatter are carefully combined. There would be no thunderous sound, only the controlled release of energy driving the ship onward at an incredible rate. Antimatter fuel is exceedingly scarce and difficult to produce and store. It remains more a dream of futurists than a practical reality. Yet in humanity's starbound dreams, this potent fuel glimmers as a hope, an engine that could one day carry vessels to distant stars by burning with the most fundamental fire the universe allows. Not all engines carry their fuel on board. Some concepts envision a spacecraft propelled by light itself, riding a beam sent from home. In the dark between suns, one might unfurl a great sail, a mirror of enormous proportions, but gossamer thin. Back at the journey's origin, perhaps orbiting Earth, a battery of powerful lasers would focus onto that sail, pouring streams of photons onto its surface. Each photon carries momentum, and when trillions upon trillions strike the reflective fabric, they impart a push, ever so gentle. At first, it is a nudge almost too small to notice, but with constant pressure over months, the ship gathers speed without expending any propellant of its own. This beamed sail concept is nearly silent. The crew would hear nothing, for the propulsion comes from a distant source of light. They simply continue to sleep as the invisible hand of a laser beam accelerates them. Over time, a sail-driven craft could reach a significant fraction of light speed, gliding on a column of radiance. The technology to achieve this on a large, crude scale remains theoretical and fraught with challenges. But in the grand tapestry of exploration, it offers an image of interstellar travel as graceful sailing through the cosmic ocean, guided by light. Each of these engine concepts, chemical, nuclear, fusion, antimatter, and light sail, represents a way to stretch the night and make the journey between stars achievable. Our starship is a culmination of these ideas. Perhaps it used a combination. chemical rockets for the early ascent, then a switch to a steady nuclear or fusion thrust for the long cruise. Or it carries advanced engines, yet untested, preparing to ignite new kinds of thrust in stages. Whatever the design, the goal remains the same: to provide sustained propulsion that can build up the enormous velocity needed to cross interstellar space. This propulsion happens not in violent bursts, but in a measured, ongoing way. In the quiet, endless night, the engine's glow is like a distant campfire in a dark wilderness. Small, but persistent. A beacon of human ingenuity, holding the cold at bay. The crew remain in their enforced slumber, oblivious to the type of fire that pushes them, feeling only, perhaps in some corner of their subconscious, that gentle acceleration as a lullaby of motion. Under the star's distant light, the spacecraft forges onward. Its engines, whichever form they take, have one thing in common. They lengthen the reach of humanity into the cosmos. In the emptiness between suns, the ship's acceleration stretches out the night, turning years of travel into something endurable, turning impossible distances into achievable voyages. Through the long voyage, the propulsion hums steadily, a quiet promise that the ship is moving, inching across light years by steadfast increments. While those on board lie in dreamless sleep, these engines carry the torch of life forward. They ensure that when the travelers next open their eyes, they will be that much closer to a new dawn in a far-off sky. In the vastness of space, acceleration becomes a whisper rather than a shout. The starship is no longer jolted by fierce G-forces as in a launch from Earth's surface. Instead, once the main engines take over in deep space, they impart a continuous, gentle push. This low thrust is unceasing, minute by minute, hour by hour, building velocity quietly. It is a far cry from the old pattern of burning hard for a few minutes and then coasting. Here, acceleration itself is a sustained state, a soft pressure that persists day after day, nudging the ship faster and faster without ever rattling its bones. Inside the ship, the effect of this constant thrust is subtle but pervasive. If one could stand in the corridors during this phase, one would feel a slight weight underfoot, even in the middle of emptiness between the stars. The direction of down is toward the ship's aft, where the engines push from. Every object has just a bit of heft. Tools left floating in the air would slowly drift toward the back of the ship and settle against a wall. A thin film of water, if spilled, would eventually form a shallow puddle on the aft bulkhead, rather than globule aimlessly. This artificial gravity is not strong, perhaps only a small fraction of what we feel on Earth. But it is steady. The human body, even in cryosleep, responds to it. Fluids that would otherwise balloon the face in weightlessness drain subtly downwards. Muscles and bones experience a gentle load, and the inner ear might sense a faint tug aligning notions of up and down. It is as if the ship creates its own tiny, private world, where gravity still exists, drawn out of the void by the magic of constant acceleration. The body adapts to this change in a slow and natural way. In earlier space eras, astronauts went from heavy gravity at launch to weightlessness in minutes, a shock to the senses and physiology. Here, any transition is gradual. Perhaps the crew departed Earth in 0G after the initial insertion into space, floating freely for a time as systems were checked. Then, as the interstellar engine engaged and ramped up over hours or days, a gentle weight returned. If any crew were awake at that time, they would feel their arms drift back to their sides and their feet find a floor. They might press a hand to a wall and notice that it now has a slight resistance, a hint of weight pressing them down. Their hearts, which worked a bit less vigorously in freefall, now adjust to pushing blood against a mild gravitational pull again. bones and muscles, which in weightlessness would start to weaken over long periods, are glad for the small exercise that even a low acceleration provides. This is the body's slow adaptation, a peaceful settling into a new normal, the quiet gravity of constant thrust, replacing the void of zero G. For the sleepers, this steady acceleration is like a cradle's rocking. They remain unaware, kept in stasis, but their bodies benefit from the stable environment. The fluid in their ears may gently move to one end of the semicircular canals, giving no signals of distress. Blood subtly shifts within them, preventing the complete stagnation that true weightlessness could bring. Even in metabolic sleep, the fact that there is a clear up and down may help their autonomic systems maintain balance. Should one of them be awakened for a periodic check-in years into the voyage, they would not find themselves utterly weak and adrift. Instead, they would wake to a ship where they can stand, albeit lightly, and orient themselves. There would be a floor and a ceiling, and their body would already be accustomed to having a sense of weight, however small. In this way, the long acceleration spares them some of the disorientation that early spacefarers faced. It is a gentler path through the physical challenges of space travel. The constant push of the engine is not merely for comfort. It also reshapes the journey in profound ways. With each passing hour of thrust, the ship's speed increases. In the first day of such acceleration, the vessel gains perhaps thousands of kilometers per hour of velocity. In a week, it is moving faster than any chemical rocket could achieve. In a month, faster still, on track to leave the solar system far sooner than the Pioneer or Voyager probes of centuries past. As velocity grows, the starship begins to compress the vast distances ahead into something navigable. The numbers become astounding. Millions of kilometers per hour, a fraction of the speed of light that inches upward relentlessly. Yet from inside, nothing appears to change quickly. The stars outside do not streak or blur. They remain pinpoints, slow to shift in the sky. The sense of motion comes not from what is seen, but from what is felt, a constant mild pressure, and from the calculations in the ship's computer, quietly ticking off the rising speed. In the silence of space, this ongoing acceleration makes no sound. There is no air to carry engine noise, so the journey unfolds in near stillness. Perhaps within the craft, there is a faint hum of machinery, the thrumming of pumps, or the whir of power systems feeding the drive. These sounds are steady and monotonous, blending into the background like the gentle repetition of distant waves. If one of the crew were briefly awake, they might find it hard to tell by ear that they are accelerating at all. Only the instruments and the gentle gravity underfoot betray that the ship is constantly gaining velocity. The traveller's sleep is undisturbed by it. The machinery's lullaby is consistent and non-jarring. Time itself becomes a curious companion during constant acceleration. As the ship's speed approaches a significant fraction of the speed of light, Einstein's laws come quietly into play. The clocks on board begin to slip out of sync with those back on Earth, ever so slightly at first. Days on the ship, from the perspective of Earth, start to become a bit shorter than days back home. The effect grows as velocity increases. At half the speed of light, time aboard might run about 15% slower relative to Earth's frame. At 90%, time might slow to less than half the Earth rate. Within the ship, everything feels normal. Seconds tick by in the same steady rhythm for those on board. But if they could see Earth's calendar, they would realize that more time is passing on the outside. This time, dilation remains an abstract concept for now. The sleeping voyagers are in no position to watch clocks or compare timelines. Nonetheless, the phenomenon is there, woven into the fabric of their journey. It means that when the crew eventually reach their destination, the world they left behind will have aged even more than they have. Through the ship's long acceleration phase, guidance and control systems ensure everything remains smooth and safe. The autopilot carefully modulates the thrust, making micro adjustments so that the acceleration stays uniform. If the engines are capable of throttling, they might slowly reduce thrust as fuel mass decreases, keeping the felt acceleration constant for the crew. Alternatively, the thrust might remain constant, causing acceleration to creep higher as the ship becomes lighter. If so, the computer keeps that increase within safe bounds. There are no sudden jerks or surges. Should a piece of space debris appear in the ship's path, the sensors would detect it long in advance, and the engines might briefly ease off or cut out, allowing a slight course adjustment, then resume their push. All of this happens without drama, a ballet of precision, so that the slumbering passengers remain undisturbed by any abrupt motion. The ship essentially surfs a smooth wave of force, the crest of acceleration carrying it steadily onward. After a long period of acceleration, perhaps many months or even years, the moment comes to prepare for the destination ahead. Far out in interstellar space, the midpoint of the journey is reached. At this time, the ship's velocity is immense, and if nothing were done, it would simply continue flying on past its target star. So gradually, the constant thrust ceases and then reverses. The spacecraft performs a slow and deliberate turn, rotating end over end until its engines face the direction of travel. There is no hurry in this maneuver. It is executed as a graceful pirouette in the emptiness, pivoting the vessel around. Once reoriented, the propulsion resumes, but now its task is to bleed off the colossal speed that has been gained. Deceleration begins, another gentle, unbroken push, but this time acting as a brake. For the crew, still in their long sleep, this flip and deceleration are as uneventful as the acceleration that preceded it. The direction of their slight gravity might shift during the turn, perhaps swirling momentarily as the ship pivots. But soon enough it stabilizes again, and they continue to feel a gentle downward pull just as before. Now, instead of pushing them from behind, the thrust is slowing them from ahead. Yet because the ship has flipped, down is still down in the habitat. The environment inside remains much the same. The floor is still the floor, and the quiet hum of the engines continues. Only now do the numbers on the instruments show that the ship's speed is steadily decreasing. Bit by bit, over long spans, the spacecraft sheds speed. The journey is far from over, but the peak of the climb has passed. Now comes the equally steady descent into the destination's gravity well. In this way, with quiet acceleration and gentle deceleration, the starship manages the Herculean task of crossing light years. It is an exercise in patience and control rather than raw power. The steady thrust gives the voyage a gentle rhythm, an outward breath as the ship speeds up, and a sigh as it slows again. Throughout it all, the crew remain asleep, their bodies softly pressed by the smallest of forces, their minds unaware of the cosmic distances shrinking around them. The universe outside races past, but inside the cabin, the pace feels almost still. It is measured by the soft thrum of engines and the gradual change of numbers on a screen. This tranquil crossing is the embodiment of a new kind of exploration. Here, progress is a quiet, continuous flow, and the travelers are carried along as if on a slow celestial river toward a faraway shore. The starship journeys through a darkness so profound that only the distant pinpricks of stars give any sense of direction. With the crew in deep sleep, the task of finding the way falls entirely to the spacecraft's automated systems. In this endless night, the ship becomes its own navigator, using the lights of heaven as its guide. Silently, it scans the star-strewn sky, recognizing patterns of constellations, just as sailors once did on the open ocean. The cosmos itself is the map, and the vessel reads it with unerring precision. On board, sensitive star trackers watch the sky constantly. These are digital eyes, cameras that capture images of the surrounding stars and compare them to an internal star catalogue stored in the ship's memory. At any given moment, the tracker might focus on a cluster of bright points, trying to match them to known constellations or star patterns. When it finds a match, the ship's computer calculates its orientation. This is the direction of Vega, that is Sirius, and galactic north lies this way. With these references, the spacecraft can align itself, knowing how it is pointed relative to Earth or to the galactic plane. This orientation is crucial for steering. Even while engines are quiet or during coasting periods, the ship needs to maintain a proper attitude. Small reaction wheels or gentle puffs from gas thrusters make tiny adjustments, turning the craft ever so slightly so that its instruments and engines stay correctly aimed. All of this happens in the background, without a sound, as the sleepers remain unaware that above them the stars are being continually surveyed and recognized. The star tracker is just one part of the navigation toolkit. Beyond simple orientation, the ship must also know its position in the vast emptiness. Far from any planet or familiar landmark, it relies on more than just visible stars for this. Here, the starship employs one of the universe's own signals, pulsars. These exotic stellar remnants spin and flash with incredible regularity, emitting beams of radiation like cosmic lighthouses. The spacecraft's instruments are tuned to detect the flickering X-rays or radio waves from specific pulsars that have been carefully chosen as navigation beacons. Back on Earth, scientists prepared a kind of galactic GPS for the voyage, a list of pulsar coordinates and their precise pulse timings. Now, as the ship sails through interstellar space, it listens for those pulses. When the detector catches the rapid beats of a pulsar, perhaps one that spins dozens of times per second, the onboard clock notes the arrival times. By comparing these to the expected timing, the computer can tell how far it must be from the known location of that pulsar. With 3 or more such pulsars in its sight, the ship can trilaterate its position, much as a navigator on Earth might use signals from multiple satellites to pinpoint a location. All of this computation occurs quietly and endlessly, refining the ship's knowledge of where it is as the years pass. Occasionally, the navigation system decides that a course correction is needed. The trajectory to the destination star was plotted long before, but even a minuscule drift or the gravitational tug of an unnoticed object can introduce slight errors. Perhaps a whisper of interstellar hydrogen has gradually nudged the ship, or a tiny misalignment in thrust added a sideways component to its velocity. When the onboard guidance notices a deviation, maybe only a few kilometers off course after billions traveled, it plans a gentle remedy. Thrusters positioned around the spacecraft fire in a carefully timed sequence. These thrusters release small bursts of inert gas or ion plasma, not enough to be violent, just enough to nudge the ship back onto its ideal path. The firings are brief and controlled, amounting to a barely perceptible shiver through the hull. The sleeping passengers do not stir in their chambers. The correction is too slight to jolt them, akin to a slight change in a breeze that one might never notice while asleep. Afterward, the ship continues coasting true, its course once again aligned with the distant target. Throughout this long journey, the onboard computer carries the responsibility of pilot and navigator with unwavering diligence. It continually cross-checks the ship's path against the mission plan that was set when the voyage began. If the spacecraft strays a fraction of a degree off its intended bearing, the system catches it. There is no drama in these adjustments. only the patient, methodical action of a machine fulfilling its duty. The navigation. I might be constantly running simulations of the trajectory, projecting where the ship will be in a year, in 10 years, and ensuring that it will pass near the target star as intended. If needed, it will adjust now in tiny increments to avoid large corrections later. It's the equivalent of a traveller making small steps to stay on a narrow trail in the dark, rather than waiting until they are lost to make a big turn. In this careful manner, the starship never strays far from its intended path, avoiding any need for dramatic last-minute changes. The dark between stars offers few obvious checkpoints, so the ship creates its own. At intervals, perhaps once every few weeks or months, a scheduled navigation update occurs. The computer might rotate the ship slightly to bring a particular guide star or pulsar into the view of a dedicated sensor for a precise measurement. Then it compares that reading with its expected position at that time. Usually, the difference is negligible, a testament to how well it has held the plan. But if there is any discrepancy, the computer notes it and calculates a correction. These maneuvers are slight and performed slowly. The spacecraft might take hours to pivot a few degrees, then correct its heading, then return to its original orientation. The entire process is orchestrated so gently that it barely interrupts the steady rhythm of the voyage. All the while, the vast starfield outside gradually changes as the ship travels onward. New constellations subtly distort. Familiar star patterns from Earth's sky grow unrecognizable over the years. The ship's instruments pick up these changes long before a human eye would. To the sleeping crew, it all happens beyond their perception. But one day when they wake, the sky they see from a window will be different from the one they remember. For now, that evolving starfield is simply data in a database, quietly logged by the navigation system. The ship is effectively alone out here, charting a path through an expanse with no signposts except the distant suns themselves. In this quiet odyssey, navigation is a symphony of precision and patience. No steering wheel is being turned by human hands. Instead, a tireless electronic mind corrects the course by millimeters at a time. Spacecraft and space cooperate in a delicate dance. The ship asks the stars where it is, the stars answer with their light and pulses, and the ship gently adjusts its path. All of it transpires in silence and darkness, a voyage guided by points of light that never cease to shine. While the crew dreams on, the starship navigates the dark with steady confidence, inching ever closer to a destination that it never loses sight of, even in the infinite night. Space may be an airless void, but it has its own kind of weather. There are no clouds or storms as we know them, yet invisible gales and squalls sweep through the cosmic sea. Radiation belts, solar winds, and cosmic rays create a shifting environment that the starship must navigate just as surely as it charts its course by the stars. The sleeping travelers are unaware of these forces, but around them their vessel quietly battles and buffers the elements of space, ensuring the journey remains safe and serene inside. When the ship first departed Earth, it crossed through regions of intense radiation encircling the home planet. The Van Allen belts, zones where charged particles from the sun are trapped by Earth's magnetic field, were an early hurdle. Within those belts, energetic protons and electrons swarm like invisible bees. The starship's path carried it briefly through this buzzing gauntlet as it escaped Earth's gravity. Inside the cabin, the passengers felt nothing unusual. There was no sign of the particle storm outside. Layers of shielding in the hull absorbed and deflected the radiation. Perhaps the ship's external sensors registered a spike of activity, triggering protective protocols. The spacecraft might have slightly altered its trajectory to minimize exposure time or powered up certain systems to full strength, but all of it happened quietly. By the time the vessel emerged beyond the belts, it was as unscathed as a traveller passing through a brief rain shower under a sturdy umbrella. Farther out, beyond Earth's immediate influence, the ship encountered the open currents of the solar wind. The sun continuously emits a stream of charged particles that flow outward, a ceaseless wind of plasma. Here, too, the starship was prepared. It carries its own magnetic field generator, powerful coils that, when energized, create a protective bubble around the ship. As the solar wind washed over the craft, these coils hummed into action. A gentle thrum might be heard in the quiet of the cabin, a low electrical murmuring at the edge of human hearing. That hum is the sound of a magnetic shield at work, a soft reassurance that the technology is guarding the crew. The ship's artificial magnetosphere deflects many charged particles, much as Earth's field does for those on the ground. Protons that might have slammed into the hull are instead nudged aside by the invisible magnetic lines stretching around the ship. The sleepers remain untouched by the solar tempest. They slumber on as their vessel calmly sheds the particles like a coat brushing off dust. Not all radiation is so conveniently diverted, however. Beyond the heliosphere, as the craft leaves the protective influence of the sun's magnetic field entirely, it enters the realm of the true cosmic rays. These are particles born in distant supernovae and violent cosmic events, accelerated to nearly light speed and now streaming through interstellar space from all directions. Unlike the solar wind, cosmic rays are fewer in number, but far more energetic. They can pierce deep into materials and are a constant drizzle throughout the galaxy. To the starship, they are like a faint, never-ending rain that gently peppers its hull. Each cosmic ray particle that strikes the ship deposits a tiny bit of energy. One might produce a brief flash of light in a sensor or a subtle spike in a radiation counter. Over years, these impacts add up, posing a hazard to both electronics and biology if not mitigated. The designers of the ship anticipated this eternal bombardment. The crew quarters and cryosleep chambers are tucked behind multiple layers of shielding materials. Water tanks, supplies, and other dense equipment are strategically placed around the habitable areas to act as barriers. Water is an excellent absorber of radiation, so storing it in a ring around the sleep pods serves a dual purpose: life support and radiation shield. Additionally, specialized plastics, rich in hydrogen, line parts of the walls. Such materials are particularly good at slowing down and stopping proton radiation. Deep within, the crew lie as if in a fortress, encased by walls of purposeful mass. The cosmic rays still come, but by the time they traverse the outer hull, the water jacket, and the inner shielding, most of their harmful energy has been spent. What remains is often insignificant, a diminished whisper of what was once a scream of energy. Even so, there are times when space weather spikes unpredictably. A distant solar flare from our sun, or even an unforeseen outburst from a passing star, can send a surge of particles coursing through space. The ship's radiation sensors remain ever alert for such events. If a sudden rise in radiation is detected, the onboard systems respond in an instant. The magnetic shielding may be increased to full intensity, causing the coils to sing a little louder as they work overtime. Non-essential electronics might momentarily power down to avoid damage from charged particles. In more extreme cases, the computer could rotate the ship so that the bulk of its mass faces the incoming wave, using the hull itself as a makeshift shield. These responses are programmed into the vessel's space weather protocols, a kind of automatic storm response plan. The adjustments are slight and measured, carried out smoothly so as not to disturb the peaceful environment within. The sleepers do not wake. They have no indication that a radiation squall may be passing through. At most, they might sense a gentle vibration or hear the soft change in pitch of the shield's hum, a lullaby shifting tone, but never ceasing. Inside the ship, the presence of this radiation shielding system is almost comforting. It is a constant, low-level assurance that in this harsh environment, there is a cocoon of safety. The hum of the magnetic coils, when audible, blends with the other background sounds of the spacecraft. The faint ventilator airflow, the soft buzz of electronics. It is steady and unvarying for the most part, a sign that all is well. To a crew member who might awaken briefly, the hum would be a familiar friend, much like the sound of rain on a roof might be comforting on Earth. It says that outside, danger may be roaming, but here inside, one is protected. Radiation can also subtly touch the human body in ways one wouldn't expect. Even with shielding, a stray high-energy particle might occasionally get through and interact with a sleeper's environment. Astronauts have reported seeing flashes of light in their vision, cosmic rays striking the retina. For our sleeping travelers, deeply unconscious, such phenomena might flicker across their closed eyes unnoticed, or perhaps weave into their dreams as faint phantom sparks. But even these rare intrusions are of no consequence. They are mere speckles of cosmic dust against the overwhelming darkness. The electronics of the ship are hardened against radiation too. Critical circuits are duplicated and encased in protective materials. Memory banks use error-correcting codes so that if a cosmic ray flips a bit in the computer's brain, it is caught and corrected without fuss. The ship's systems, much like the crew, have layers of protection to keep them functioning normally under abnormal conditions. The gentle hum of a power regulator might change subtly when it corrects a voltage spike induced by a particle, but the correction happens in a split second, and life on board goes on undisturbed. Thus, as the starship ventures through regions of radiation and cosmic rays, it carries its own calm weather with it. Outside might rage an invisible storm of particles, but inside is an oasis of tranquility. The interplay of magnetic fields and physical shields ensures that the environment within remains as gentle as a spring morning, despite the lethal haze outside. The sleepers continue their long rest, bathed in the soft blue glow of their life support monitors, never feeling the cosmic rain that falls on the hull. In the voyage between stars, the ship becomes a tiny world of its own, complete with an artificial atmosphere and an artificial magnetosphere. It maintains a bubble of habitability against the void. The weather of space may howl, but it is kept at bay by engineering and vigilance. What remains is nothing more than a faint and soothing hum around those who dream on in peace. The interior of the starship is a quiet haven, a tiny habitat carefully maintained against the stark extremes of space. Every system that keeps it alive operates with a deliberate hush, as if mindful not to disturb the sleeping passengers. Temperature, air, gravity, all the conditions of a world are recreated on board in microcosm. Tended gently and persistently, it is an artificial womb for its crew, balancing warmth, airflow, gravity-like forces, and even a touch of nature, all while barely sipping at the limited energy available. Thermal control is one of the silent caretakers. In space, heat can only escape by radiating away. Without careful management, parts of the ship could freeze in shadows or bake in sunlight. To prevent that, a network of coolant loops winds through the vessel, carrying excess heat from where it's produced to radiator panels on the hull. These radiators extend like broad petals into space, unseen by the crew, but constantly at work. They glow in infrared, shedding warmth as faintly as a quiet sigh into the cosmos. The fluid that runs through them moves continuously, driven by pumps designed to be almost noiseless. A faint vibration may tickle the structure, the slightest hint that coolant is flowing, but it's a subtle whisper in the background of the ship's soundscape. Within the walls, heat exchangers gently transfer warmth from electronic equipment and life support systems into these coolant streams. The air inside the habitat stays stable and comfortable, never too cold or too warm. If one could float in the cabin, one might notice subtle gradients of temperature. A slightly warmer surface on a panel here, a cooler draft down a corridor there. These are the byproducts of thermal balance being achieved. When a piece of equipment gives off heat, sensors detect the rise by a fraction of a degree and command the coolant to whisk it away. If a shadowed part of the ship cools too much, heaters softly cycle on to keep it at the right temperature. All of this happens without any dramatic fanfare. Just the gentle cycling of fluids, the opening and closing of tiny valves, and occasional soft clicks as thermostatic systems adjust. To the sleepers in their cryobeds, it's utterly imperceptible. They rest in an environment that remains as calm and steady as a twilight room, thanks to this constant, quiet thermal vigilance. Gravity, or something like it, is another element that the habitat provides in measured doses. While the ship's acceleration often created a gentle downward pull, there are phases of the journey when engines are inactive, coasting silently. During those times, the vessel can become a floating world without up or down. To avoid long periods of weightlessness, the starship employs a slow, steady rotation. Deep in its design is a spinning section of the habitat, perhaps a circular ring or an internal carousel that turns at a carefully controlled rate. It spins so gently that loose objects don't fly off. The rotation creates just enough centrifugal force to mimic a light gravity along the outer edge of that section. This artificial gravity is very mild, maybe a tenth of Earth's pull or less, but it gives directionality to life on board. Even if the crew is asleep, their bodies benefit from this orientation. Fluids settle, bones and muscles feel a hint of weight, and there is a defined floor and ceiling in the habitat module. The mechanism that maintains this spin is engineered for quietness. Electric motors increase or decrease the rotation almost silently, using magnetic bearings that reduce friction. If one were awake inside, one might only notice the spin by the behavior of objects. A floating speck of dust drifts subtly towards what has become the floor, or the way a hanging strap now leans outward. The rotation itself is too slow to produce any disorienting sensation. It is more akin to the gentle turning of a Ferris wheel than a whirling carnival ride. There might be a distant hum from the motor when it first starts the rotation or adjusts its speed, but once at steady state, even that fades away. The ship rotates at a constant pace, and everything aboard moves with it as one. No noise or jolt betrays that this artificial gravity is constantly being made. In the cryosleep chambers, the sleepers remain comfortably nestled, their bodies subconsciously grateful for a touch of normalcy, a sense of down, even though they do not wake to appreciate it. Maintaining a breathable, clean atmosphere is another essential task carried out in hush. The air inside the starship is recycled in a closed loop, refreshed and scrubbed continuously. Rather than loud compressors or fans, the vessel uses low-power blowers and gently circulating air currents to push the atmosphere through filters and regenerative systems. Carbon dioxide exhaled by the crew when they were awake, and even the small amounts their bodies release in sleep, is absorbed by chemical scrubbers or dissolved into water to be processed. In one corner of the life support bay, a quiet chemical reactor converts that CO2 back into oxygen, perhaps aided by a tiny ecosystem of algae. Transparent tanks house cultures of green microalgae bathing under dim, energy-efficient lamps. These organisms feed on the carbon dioxide and light, growing slowly but steadily, and releasing oxygen as a byproduct. The lamps glimmer with a subdued glow, on a day-night cycle tuned to the algae's needs, casting a gentle emerald tint that hardly spills into the main habitable areas. The algae farm works silently. One might see a lazy trail of bubbles rise in the solution as oxygen is produced, but not hear it. The entire system sips only a small fraction of the ship's power, a living machine working in tandem with mechanical ones. Elsewhere, a miniature garden of microbes tends to the water and waste. In small, sealed bioreactors, colonies of bacteria break down impurities and generate useful gases or nutrients. This forms part of the spaceship's micro-ecosystem, a collection of life forms and processes that recreate the recycling that happens in Earth's biosphere, albeit on a tiny scale. There is a kind of poetry to it. Human explorers venturing far from Earth, yet carrying a spark of Earth's life with them to sustain them. These bacteria and algae are humble passengers, never seeing the stars, but their existence on board is vital. They quietly purify water, regenerate air, and might even help produce basic food ingredients or nutrients. They work constantly and quietly, asking only for a bit of warmth and light, which the ship provides sparingly. In return, they keep the environment wholesome and alive. The habitat's climate is thus maintained by a symphony of subtle, interlocking systems. Fans murmur softly as they draw air through filters that remove any trace contaminants. Moisture from the air condenses on cool coils quietly, providing drinking water and keeping humidity in balance. Then that water is cycled back into use. Not a drop is wasted in this closed world. The lighting in inhabited sections, those not darkened for the long sleep, is kept low and golden to mimic an evening glow, calming and easy on the eyes. Or it would be, if any eyes were open to see it. Occasionally, a robotic attendant glides through the corridors, checking sensors or trimming the algae growth. It performs its duties with near-silent electric motors. This too is part of the hush, the absence of human chatter or commotion, replaced by the soft whir of servos and the gentle sigh of moving air. Every few hours, the central computer runs diagnostics on the habitat systems. It might incrementally adjust the spin rate by a fraction of a percent, or dial the coolant pump slightly faster if a particular zone is warming. Each change is small and gradual, never jolting the equilibrium. The result is an interior that feels static and calm, even as myriad adjustments happen in the background. The travelers sleep on, never knowing how finely their environment is being tuned around them. To them, there is only the experience of a stable, tranquil cocoon. From outside the closed hull, one might see nothing of this intricate ballet. The ship drifts through space, its radiator panels faintly aglow, its habitat module perhaps slowly rotating. The only hints that inside, an entire living environment is being sustained. But step inside, and you would find the air fresh and mild, the floor with a faint gravity-like tug, and the ambience akin to a quiet morning at home. This is a habitat in hush, where technology and a touch of biology work hand in hand, silently securing a livable oasis in the void. It is the epitome of gentle stewardship. Machines whispering instead of roaring, ecosystems flourishing in miniature, and a spaceship that feels, in its own small way, like a peaceful home for those who reside within it. Long before the crew will open their eyes again, the starship has been preparing for their nourishment. Food for the journey and for the arrival beyond has been carefully considered and quietly managed over the many miles of transit. In the silence of the ship, there is a slow, deliberate cultivation of sustenance happening alongside the maintenance of air and water. It's a process that spans years, all so that when tomorrow comes for these sleeping travellers, they will have something wholesome to eat and the strength to carry on. The first aspect of this preparation is the cache of stored nutrition on board. Before departure, the ship was packed with a pantry designed for decades. Shelves of vacuum-sealed packs, dehydrated meals, and nutrient-dense concentrates line a storeroom deep in the vessel. These rations are engineered to last. Grains are powdered and sealed with oxygen absorbers. Meals are freeze-dried into lightweight bricks that only need water and heat to spring back into form. There are jars of vitamins and minerals, carefully shielded from radiation to prevent potency loss. Everything is labelled in plain text and tactile marks so that groggy crew members with dim lights could find what they need. For now, this storeroom sits in darkness and quiet chill, a library of meals waiting to be used. No one rifles through it. No one cooks or crunches a snack in the galley. Only the soft whir of the ship's circulation fans touches the still air around these provisions. The food sleeps, in a sense, alongside its future eaters. Yet stored food alone is not the complete solution for a journey of this length. Nutrients can degrade over time, despite our best preservation methods, and nothing truly fresh can survive being stored for decades. So the starship carries life in its belly to grow new nutrition en route. In a small, climate-controlled compartment, a slow-grown harvest is taking shape. Bioreactors quietly hum as they cultivate simple organisms that will become food. One tank might hold a strain of edible algae, chosen for its high protein and vitamin content. Fed on light and a trickle of recycled nutrients, it multiplies at an unhurried pace, forming a green mass that can be skimmed and dried when needed. Another vessel contains a culture of yeast or single-celled fungi, growing on sugars derived from recycled plant matter. Over the years, these microorganisms produce biomass rich in amino acids, a microbial crop that can be processed into something akin to flour or paste. This growth is incredibly slow by farming standards. There is no rush in deep space. Under dim LED lights that mimic perpetual dawn, the algae and yeast are content to grow gradually. They require little attention. An automated stirrer turns them occasionally. A sensor checks their density. A pump gives a measured dose of nutrients, all with hardly a sound. A person standing next to these bioreactors might only hear a faint bubbling or the soft hum of a low-speed agitator. In that white noise, a new meal is being born, grain by grain of biomass accreting for future use. By the time the crew wakes, these reactors will have accumulated a reserve of edible material. It won't be a gourmet feast on its own. The output is a bland, doughy substance or a dried algae cake, but it provides essential proteins, fats, and vitamins. Mixed with water and perhaps the flavors carried in the stored spices and seasoning kits, it can become broths, shakes, or breads to fortify the travelers on the next leg of their adventure. In addition to these microorganism farms, the ship carries seeds and starter cultures for plants that will never sprout until needed. Tucked away in refrigerated drawers are packets of heirloom seeds, hardy greens, nutrient-rich vegetables, perhaps even a few herbs or fruiting plants. These are insurance for tomorrow. Maintaining a big garden during the high-speed cruise would be impractical. Once the ship slows and the crew nears their destination, some of these seeds could be planted in a small hydroponic chamber. Under gentle lamplight, shoots could emerge, giving the crew fresh leafy vegetables or a juicy treat to supplement their diet after years of preserved fare. The equipment for this hydroponic garden remains stowed for now. Trays, nutrient solutions, tiny scissors for pruning, all waiting quietly for the day they are called to action. In the meantime, The knowledge that living plants will once again grow on this metal vessel is a silent promise of renewal. As important as the food itself is the crew's ability to digest it. A long time in stasis or on minimal diet can wreak havoc on the trillions of beneficial bacteria in the human gut. These microorganisms are essential partners. They help break down food, produce vitamins, and support the immune system. Before the journey, each crew member's microbiome was catalogued, and samples of key gut bacteria were cryogenically preserved on board. During the voyage, with the crew in deep sleep and minimal nutrition, their intestinal flora likely dwindled. The mission designers anticipated that once the crew awakens and resumes eating, they will need help to re-establish this internal ecosystem. The medical bay and galley hold stored cultures ready to brew into probiotic drinks or yogurts when the time comes. Perhaps a day after revival, each crew member will sip a bland, milky concoction teeming with billions of friendly microbes cultivated from their own pre-launch samples. These little beings, revived from dormancy, will journey into their host's intestines and set up shop anew. It's a quiet reunion of sorts, the body regaining its long-lost companions. The process is gentle. There is no fanfare as the bacteria multiply and colonize, just a gradual repopulation that helps the crew digest the rich foods they'll soon consume and protects them from harmful invaders. Even the act of eating again is planned to be gradual and careful. The ship's systems will likely wake the crew with a regimen of easily digestible nutrients first. Perhaps warm liquids, enriched with the algae-grown proteins and a mild carbohydrate base, will be fed to them slowly, almost like feeding an infant after a long illness. The dining area of the ship remains unused for now, but it's kept ready. Cabinets hold lightweight plates and utensils designed to magnetically stick to tables in case of low-gravity meals. There might be a compact food warmer awaiting its first use since launch. When a crew member finally sits down to eat a solid meal, it may be decades since they last chewed and savoured food. The ship ensures that their first bites will be nourishing and safe. Soft foods, mild flavours, packed with the calories and electrolytes their atrophied muscles and shrunken stomachs will crave. Throughout the voyage, the care for food and nutrition happens quietly and mostly automatically. A small display in the life support control panel perhaps shows status bars. Algae culture, 80% to target mass. Or yeast reactor, harvest ready in 30 days. No one is actively monitoring these readouts now, except the ship's AI, but they provide reassurance that the food systems are on track. If a parameter drifts, say the algae growth slows due to a lamp failing, the computer notes it and activates a spare lamp or rebalances the nutrients. There is no panic, just methodical correction. The crew will never need to know that at one point the algae were a bit sluggish. When they wake, they will find the stores full and the cultures thriving. In the stillness of the interstellar night, the starship nurtures these small life forms and stockpiles nourishment, much like squirrels, caching acorns for winter. It is an act of foresight and patience. No dramatic harvests mark the time, only the slow accumulation of jars and packets, and the unseen multiplication of microscopic cells in their warm broths. When the crew finally stands in the galley, groggy but alive, they will be greeted by the fruits of this long labour. Shelves of food ready to be hydrated and heated, tubs of fresh-grown nutrients to mix in, and perhaps a few sprigs of something green and growing to remind them of Earth's bounty. Thus, food for tomorrow is being quietly prepared today, every day of the voyage. The travellers sleep peacefully, unaware that their ship is in a sense cooking in ultra-slow motion. The rewards of this patience will be felt when human voices and laughter return to the dining table, and a simple meal in the stars becomes possible. All the while, the starship carries within it the means not just to keep its crew alive, but to let them live, to taste and to enjoy, to be strengthened and healed once their long sleep ends. In the grand silence of space, a subtle promise is kept. Rest easy. I will get you there, come what may. Silently standing vigil over the crew is the ship's physician. Not a person, but an ensemble of advanced systems designed to preserve life. In the stillness of the medical bay, machines and software together fulfill the role of doctor, surgeon, and nurse, all while the crew dreams on. The starship's medical intelligence monitors each sleeper with unwavering attention. Heartbeats, breathing rates, blood chemistry, even neural activity, all are tracked through sensors embedded in the cryochambers and in the crew's own vital sign implants. Should anything drift out of the safe range, the ship's physician knows, and it will act in the gentlest way possible to correct it. One of its most remarkable capabilities is autonomous surgery, a function one hopes never to need, but that is ready nonetheless. In the corner of the med bay, under a sterile drape, lies a robotic surgical unit. It resembles a high-tech cocoon or an oversized pod. If a medical emergency arises, say a ruptured appendix, an internal injury, or a malignant growth detected, the affected crew member's cryosleep chamber can be moved or opened into this unit. The system can perform operations with no human hands, guided by its programming and real-time imaging. Multiple articulated arms, equipped with laser scalpels, microforceps, and suture tools, can descend with precision on a patient. The patient would be kept in a state of deep anesthesia, likely an extension of their cryosleep, so they feel no pain and do not wake. In near silence, the machine could excise an inflamed organ, repair a damaged vessel, or even remove a tiny tumor that it found during routine scans. It does so with a steady, unhurried calm. No panicked voices, no hurried footsteps, as in a traditional emergency room. Only the slight whir of actuators, and perhaps a soft electronic tone as it communicates status to the central computer. Routine health maintenance is also happening quietly at a microscopic level. The ship's medical system employs nanomedical maintenance, swarms of tiny engineered devices that travel through the crew's bloodstreams and tissues. Long before any problem becomes macroscopic, these nanobots are at work, inspecting and repairing. Some patrol the blood, gently scraping cholesterol from artery walls and keeping vessels clear. Others monitor cells for DNA damage. If cosmic radiation has broken a DNA strand or caused a dangerous mutation, the nanobots might trigger the cell to repair itself, or even selectively eliminate the faulty cell. There are nanoscale machines that attach to red blood cells to boost their oxygen-carrying capacity, and others that sit along muscle fibers, giving minute electrical stimulations to prevent too much atrophy. All of this happens without conscious sensation. The sleepers do not feel the millions of tiny caretakers coursing through them. At most, if they were awake, they might occasionally sense a mild warmth or tingling as nanobots cluster to heal a bruise or fight a brewing infection. But asleep, they sense nothing. The care is that thorough and that subtle. While nanobots care for the body's fine details, more conventional systems manage the overall physiology through slow-dose pharmacology. Each crew member's cryopod doubles as a sophisticated IV drip and pharmacy. Instead of administering drugs in large jolts, the system infuses them continuously in tiny, measured amounts, mirroring how a healthy body might gradually release hormones. A cocktail of medications flows into each sleeper's veins in response to their needs. For example, anticoagulants seep in at a low rate to prevent blood clots from forming during long periods of stillness. a mild muscle-preserving agent might be released to signal muscles and bones to hold on to their tissue and calcium, minimizing wastage. Sedatives and metabolic suppressants are delivered in precise dosages to keep the crew in their suspended state, their bodily functions slowed to a safe minimum. Electrolytes and hydration are balanced via slow drips of saline enriched with necessary salts, ensuring that even as they don't eat or drink, their body's cells remain bathed in the proper nutrients. These drugs are adjusted automatically by the ship's AI doctor. If sensors detect a rising stress hormone level in a sleeper, perhaps indicating a troubling dream or pain response, the system can microdose a calming agent or adjust the sedation level by an almost immeasurable amount. If blood tests, performed automatically by small robotic needles that periodically sample the crew's blood, show a dip in thyroid hormone or an imbalance in any biochemical marker, tiny reservoirs of the needed substances are opened to correct the drift. The changes are so slight and gradual that the crew's bodies likely never notice a difference. They remain in homeostatic equilibrium as time flows on. Periodically, diagnostics are run in a more comprehensive fashion. The medical bay includes imaging equipment, compact MRI, and ultrasound devices slide beneath the bunks to scan organs and tissues on a schedule. This might happen only once a year, or at whatever interval the mission planners deemed prudent. When it does, a faint humming might arise as magnetic fields align, or as high-frequency sound waves gently probe the sleeper's organs. The ship's physician compares these images against baselines taken at launch. Most often, these checkups find nothing of concern, a testament to how well the nanobots and steady medications are doing their jobs. But if anything is amiss, the system notes the change. Perhaps a tiny kidney stone is forming. A nanobot swarm can be directed to break it down early. Maybe a bit of scar tissue is developing in a joint. Physical therapy routines can be initiated by stimulating that limb or adjusting the sleeper's position slightly. On rare occasions, a bigger issue might be found, something calling for that autonomous surgery to awake. If so, the system will decide whether it's safer to intervene immediately or to gently wake the person for treatment. But the design is such that almost any treatable condition can be handled without waking the patient and without undue risk. In the background of all these interventions, the medical logs are meticulously updated. Every dose of medicine, every action of a nanobot, every anomaly detected and corrected is recorded with timestamps. The ship's physician keeps a detailed health record for each crew member that they can read upon waking, if they choose, to know what transpired during their long sleep. It's akin to waking up from a surgery and reading the surgeon's notes. Here the surgery might have been a decades-long maintenance procedure, but the notes are there all the same, quietly documenting the care provided. The presence of such a thorough medical guardian allows the crew to sleep without fear. Illness, injury, even aging itself to some extent, are being held at bay. If one could peek into the medical bay during the middle of the voyage, it might be strangely serene. The robotic arms are folded at rest, bathed in standby lights. The monitors show stable lines and numbers. Now and then a syringe on an automated injector presses down ever so slightly, delivering a few more microliters of drug into a line. Now and then a tiny drone might flit from one pod to another, carrying a fresh cartridge of medicine or a blood sample to the analyzer. The sounds are those of a quiet hospital at night. The occasional soft beep, the whisper of mechanical movement, the gentle whoosh of air in a ventilator or cooling system. This silent caretaker never grows tired and never misses a detail. Through the long dark of space, the ship's physician carries out its duties with devotion programmed into its very circuits. When the crew finally awakens, they will likely do so smoothly, helped by the system tapering off the sedatives and warming their bodies. They may feel stiff or weak, but they will be alive and as healthy as technology can keep them. The doctor will have been at work all along, making sure their hearts are strong, their minds unharmed, and their bodies ready to function again. In a journey where human frailty might have been a limiting factor, this tireless, gentle medical presence ensures that those aboard remain not just alive, but as whole as possible. It provides comfort in absentia, the kind of comfort that comes from knowing that someone or something is watching over you carefully while you cannot watch over yourself. In the great sleep between stars, the crew's well-being is cradled in competent, mechanical hands, and the ship itself becomes their physician, healer, and guardian angel in the void. A starship, venturing across decades, must be designed not only for success, but for failure as well. In the planning rooms back on Earth, engineers mapped out countless what-if scenarios, creating a vast fault tree of possible troubles and their solutions. This careful forethought lives on within the ship's computer. At every moment, the starship is running internal diagnostics, checking its own health against this tree of contingencies. Most issues are minor and handled automatically long before they escalate. If a circuit shows signs of overheating, it is quietly shut down and a backup takes its place. If a thruster reports inconsistent performance, the navigation algorithm compensates with others and marks the thruster for later inspection. The guiding principle is clear. No single failure should doom the mission, and even multiple failures should be managed with grace, not panic. The ship is built with layers of redundancy. There are extra pumps, extra processors, extra sensors tucked away like spare organs. Many of these lie dormant until needed. For instance, 5 gyroscopes might be installed where 3 would suffice for navigation. If 1 or 2 fail, the others smoothly take over without any loss of stability. Critical systems like life support have triple redundant power supplies and backup machinery that can run at a moment's notice. This means that when a part inevitably wears out or an unexpected fault occurs, the travelers don't awaken to an alarm siren or a crisis. More often, they never know anything was amiss. The ship reroutes power, switches to backup hardware, and maybe closes a valve or two, all per its pre-programmed fault responses. It's a bit like a competent crew in its own right, moving to address any leak or spark before it can grow. Consider a small, imagined incident. A micrometeoroid, a tiny pebble from an ancient comet, streaks unnoticed through space and strikes the ship's hull. It punches a pinhole in an unmanned storage bay near the ship's aft. In less than a second, pressure sensors detect a sudden drop in that compartment. Instantly, sealed bulkheads isolate the bay, preventing precious air elsewhere from rushing to the breach. The crew remains safely ensconced in their chambers. They do not even feel a change in pressure or hear the faint hiss of escaping air. The storage bay, now exposed to vacuum, is not critical. Perhaps it holds some spare equipment or consumables. The ship's system logs the event and dispatches a small maintenance drone. In the silent bay, under the beam of the drone's worklight, an automated patch kit is applied to the interior wall. The tiny hole is sealed without fuss. After a thorough check, the bulkheads reopen and normal atmosphere is restored to that space. In the ship's daily report, this registers as a brief note. Minor hull breach in Section 7A, automatically repaired. It's likely the crew will only read about it when they wake, marveling at how even tiny dangers were managed while they slept. Not every scenario can be solved without human intervention, and the designers knew this. That is why the mission profile includes the possibility of partial wake cycles. The journey is long, and while the goal is to let the crew rest until they arrive, the ship is prepared to rouse them if needed. There are plans for periodic check-ins, where one crew member is awakened to inspect critical systems manually. Perhaps every decade or so, a single individual is brought out of cryosleep for a short time. They would drift through the quiet vessel, conducting a hands-on examination of machinery that normally only robots see. With tablet in hand, they might walk the corridors, listening for any unusual vibrations, recalibrating sensors that have drifted, or performing maintenance too complex for automatons. During these wakeful interludes, the ship feels a subtle shift, a human heartbeat and footfall among its mechanical rhythms, a voice murmuring into logs or to the AI. These check-ins are both a precaution and a reassurance, designed to catch any subtleties a machine might miss and to give the crew agency in their fate, even while mostly asleep. If the awakened crew member finds nothing amiss, they can return to stasis with confidence that all is well. The cryo process can be repeated safely, especially with the advanced medical support on board to guide them back into slumber. Then the ship continues onward, once again populated only by sleepers and automated attendants. In the event that something is truly wrong, say a system requires a repair that robots cannot manage, or a decision must be made that exceeds the AI's programming, the protocols allow for more crew to be awakened. The fault tree logic will escalate issues in a measured way. First, a single person, perhaps the chief engineer or mission commander, would be revived. If one set of hands and one mind aren't enough, gradually others can be brought out of sleep to assist. This staggered approach ensures that the crew's limited waking resources, their time, their health, are only spent when absolutely necessary, and even then, as sparingly as possible. All the while, the concept of graceful degradation underpins every system on the ship. Over decades, certain components will inevitably degrade. Solar panels might collect dust or microcracks, engines will erode from firing, batteries will hold less charge, and the reactor's output may slowly wane. But everything is sized with margins and designed to decline in predictably gentle ways. As power systems age, the ship can gradually shed non-essential loads. Perhaps the interior lighting is dimmed slightly over the years, or some laboratory equipment stays offline until needed. The crew's environment and critical functions are preserved at all costs, while luxury or redundant features can quietly fade out if power must be conserved. Similarly, if propellant reserves run lower than expected, the navigation system might subtly alter the deceleration profile to use what remains most efficiently, perhaps lengthening the braking period, but still ensuring arrival at the destination. If one of two communication antennas fails far into the journey, the ship will rely on the second, maybe with a slight drop in bandwidth, yet still enough to send status messages home or receive updates. None of these adjustments compromise the safety of the mission. They simply reflect a vessel intelligently adapting to the realities of time and use. In the grand scheme, these strategies mean the starship can limp rather than crash, bend rather than break. A failure isn't a sudden catastrophe, but a cue to reconfigure into a slightly different, still functional state. By the time the crew awakens near their destination, the ship around them may not be in pristine, factory-new condition. Indeed, it will bear the scuffs and tiredness of long travel. But it will still be intact and working, with redundancies to spare. Perhaps some sections will be cordoned off where systems finally gave out, or certain backup devices will have been expended dealing with surprises. The crew might walk its halls, noting the wear and tear. Each mark a story of a challenge overcome in their absence. Throughout the voyage, the passengers remain cocooned in security, unaware of the ship's constant vigilance. They do not hear the small alarms that occasionally ring in the AI's virtual ears, nor do they witness the flurry of electronic activity as the ship decides how to respond. Their sleep is uninterrupted by these dramas. The only hints of such events lie in the ship's logs, which will one day brief them on all that transpired. In this way, the journey is not one long leap through peril, but a series of manageable steps, each contingency met with a calm solution. The starship does not expect perfection of its parts, only resilience. Every bolt, circuit, and line of code has been imbued with that resilience, the ability to fail gracefully rather than catastrophically. As the vessel coasts into the latter stages of its voyage, it does so with the confidence born of tested systems and resolved challenges. The sleepers remain in their dreamless rest, carried safely by a machine that knows how to heal itself in 1,000 small ways. And should the long night yield any new threat, the ship stands ready to meet it, or to gently wake guiding hands to help, as the very last resort. The journey continues, steady and self-correcting, a testament to foresight and the art of graceful degradation. In this steady progression, one can sense the ship's quiet promise to its passengers. Rest easy. I will get you there, come what may. Out beyond Earth's warm halo, explorers drift in a domain where human laws were never meant to reach. In this quiet emptiness, a question arises gently. Whose rules still hold this far from home? The travellers carry with them the traditions and laws of Earth. But in the endless night of interstellar space, those laws feel abstract and distant. Millions of miles or more from any court or country, the idea of jurisdiction becomes a ghostly echo. There is no border patrol in the void, no cosmic police cruising between stars. Instead, the crew of a lonely vessel must become a world unto themselves, guided only by what they brought with them. They left Earth as citizens of nations with proud legal codes, and their ship itself was launched under the flag of one country, or perhaps a coalition of many. Treaties signed decades or centuries earlier declare that the state of a spacecraft's registry carries its laws aboard with it. In principle, those laws remain in force inside the hull, protecting rights and defining duties. Yet as the distance grows, enforcement becomes theoretical. If a crime were committed in the silence between solar systems, who would investigate? Who would trial or judge? The nearest judge might be light years away, and signals carrying evidence or pleas for help would crawl slowly across the gulf. The crew knows this, and perhaps that knowledge fosters a deeper sense of responsibility among them. Far from home, they become both citizens and guardians of their own tiny domain. In the metal corridors of their ship, they strive to honor the principles they left Earth with: fairness, respect for each other's rights, the rule of law, even when there is no authority watching over their shoulders. It is a quiet pact in the dark, to uphold the best of humanity's rules, even as they slip the bonds of Earth's gravity. Still, the isolation raises novel questions their ancestors never had to face. Consider the legal puzzle of cryosleep itself. Each traveller willingly surrendered themselves to an artificially extended slumber. Before departure, they would have signed documents consenting to this long sleep, acknowledging risks that could not be fully known. The law demanded their informed consent, that they understood they might age slowly or not at all, while the universe continued without them, that they might awaken to a world changed beyond recognition. With clear heads, they accepted terms and placed their trust in technology and the crew or machines that would watch over them. This arrangement is not unlike a medical patient granting doctors permission for a risky procedure under anesthesia. But here, the procedure lasts years or decades, and the operating room is a spaceship gliding between stars. In their sleep, travellers cannot say if they feel pain, or if they have changed their mind, or if they want to wake early. They rely on the promise that their wishes at launch will be honoured until journey's end. To cover such cases, all signed contracts and advanced directives on Earth, documents stating their will for various scenarios. Perhaps they specified that if an emergency arises, they should be awakened for a say in their fate, or instead entrusted all decisions to the captain or an AI, preferring to sleep through any crisis unless necessary. Such documents attempt to project human choice across time and unconsciousness, a fragile hope that our autonomy can endure even when we are not awake to exercise it. In these agreements lies the concept of custody over the passengers' futures. Who holds the responsibility for those sleeping souls while they cannot act for themselves? It might be a ship's captain who serves as a kind of guardian, or a council back on Earth monitoring the mission remotely. It could even be an artificial intelligence entrusted with the crew's care, carrying the weight of dozens or hundreds of lives frozen in its memory banks. This custodianship is a solemn duty. If something goes wrong, a system failure or navigational peril, the custodian must decide how to respond. They might wake the sleepers, attempt a repair alone, or even alter the mission entirely. Every choice carries enormous weight, since the sleeping travelers have no voice in that moment. The law struggles here. On Earth, guardians of children or incapacitated adults must act in the ward's best interest. But how to define best interest so far from home, in situations no lawmaker imagined? What if the ship must detour around a hazard, adding years to the journey? Can the captain or AI make that choice alone? Legally, necessity might justify it. Morally, the weight of altering their passengers' futures would remain. In deep space, the letter of Earth's laws may falter, but their spirit must persist. The spaceship is a microcosm of society, bearing human values across the cosmos. The crew, whether awake or asleep, depend on a shared trust. Trust in each other's integrity, and trust in the agreements made before eyes closed for the long night. Invisible though it may be, a thin chain of law and consent connects them back to Earth, providing comfort that even in the vast unknown, they are not beyond accountability or care. Under the glowing panels of the command deck, a lone officer may stand watch while all others sleep, aware that they hold lives in their hands. That officer might reflect on the laws they swore to uphold, maritime traditions repurposed for space, or new interstellar regulations drafted at mission start. Perhaps there is a quiet ceremony of reading these oaths aloud before everyone enters the cryo chambers, a final affirmation that honor and duty do not sleep, even when the crew does. Such rituals remind everyone that while space is lawless in itself, humans carry laws within them. There may come a time in the journey when a decision tests these principles. Imagine a scenario. A single cryopod shows signs of failing far from any help. The sleeper inside is in danger. The caretaker, human or AI, faces a dilemma with no easy precedent. Do they try to revive the person immediately, risking shock and possibly death? Or do they keep them in stasis and attempt a repair? Perhaps the crew had agreed on guidelines for such events back on Earth, written into the mission charter. If those guidelines exist, they serve as law in this distant place, and the caretaker follows them as a judge would follow a statute. If no rule covers it, then in that lonely moment, the custodian must use their best judgment and the ethics ingrained in them by a lifetime under Earth's sky. As the ship continues onward after such a trial, one hopes the choice was wise, and the law, informal as it was, held true. The sleeping ones would know little of the drama that passed while they dreamt. But when they wake, if they wake, they will trust that their rights were respected in their absence. The laws that protect them are more than words on paper. they live in the actions of those who stayed awake to guard their journey. All these considerations travel with the vessel like an invisible cargo of human order. The idea of jurisdiction stretching across the void is strange, yet without it, the voyagers would be truly adrift, not just physically, but morally. Thus, they uphold a framework of accountability. The ship is registered, the mission agreed upon, each sleeper's consent obtained and recorded. Everyone knows who is in charge of decisions in their slumber. Everyone has, in a way, appointed a trustee for their hopes and dreams, while they cannot steer their own fate. This structure gives them comfort as they surrender to the unknown. With their legal and personal affairs in order, they slide into the cryopod with some peace of mind. They have prepared wills, arranged caretakers for any children left behind, and given power of attorney to someone they trust for matters on Earth during their long sleep. They have, essentially, paused their lives in a legal sense too, putting faith in a scaffold of law and duty to bridge the gulf until they resume living. Laws of Earth, however, were conceived for people awake and active, for societies in constant contact with themselves. When stretched over decades of silence, these laws will inevitably fray in places. The crew might confront issues nobody considered. Perhaps a sleeper gives birth en route, the baby gestating while the mother sleeps. An unlikely but not impossible scenario with advanced technology. Would that newborn citizen fall under the jurisdiction of Earth, or become a citizen of nowhere, born in transit beyond any planet? Questions like this show how our frameworks might struggle to contain the vastness of possibility in deep space travel. At the journey's outset, the best minds on Earth would try to anticipate and legislate. There would be conferences on interstellar law, white papers on space jurisdiction, and passenger rights. The mission planners would draft robust codes of conduct for the crew and any AI, trying to foresee each contingency. This preparation is humanity's way of extending a safety net under the acrobatic feat of crossing the stars. Yet for all the foresight, flexibility and compassion will be needed out there. The letter of the law might be less important than the character of those entrusted to carry it out. In the silent distances where no nation's flag can be seen waving, the law lives on in the hearts and agreements of the travelers. It gives structure to their actions, a promise that even while one is in dreamless sleep, they remain a person with rights and dignity, not cargo. This assurance, subtle but vital, travels with them like a quiet heartbeat under the ship's walls. Even in utter solitude, these agreed principles stand as a faint light guiding them onward. Yet for all the structure law provides, it cannot answer everything. The very act of pausing life for so long carries an ethical gravity that floats unanswered in the dark. They have trusted themselves to the long pause, but trust alone cannot answer the quiet moral riddles that accompany it. What does it mean to press pause on a human life for years, or even generations? The laws provide a framework, yes, but beyond laws lie the softer questions of right and wrong, questions whispered in the stillness of space. Each sleeper embarked willingly, believing in the mission and accepting the risks. Yet as they drift in dreamless suspension, they carry no awareness, no voice, and that very silence asks us to consider, have we done right by them? One core principle guiding these voyages is autonomy, the right of each person to make decisions about their own life. Every crew member chose this fate, signed the forms, and stepped into the pod by their own free will. This voluntary choice is the ethical bedrock of the mission. Without it, cryosleep would be an intolerable violation. No one was forced into slumber against their wishes. Still, autonomy does not end the moment they close their eyes. True respect for their personhood means honoring their choices, even while they sleep. They cannot speak up now, so the choices they made earlier must echo through the long night. If one member decided they wanted to be awakened under certain conditions, those wishes stand as a beacon for whoever is awake to follow. Imagine a crew member who, before departure, insisted on an option to be revived if a major decision about the mission arose. Perhaps she said, "If anything drastically changes our destination, wake me. I want to say." Now, mid-voyage, the ship receives new data about the target planet. Maybe a signal that it's inhabited, or a catastrophe making it unviable. The ethical question looms. Should the Guardians wake her to discuss a potential course change, respecting that earlier request? To do so would honor her autonomy, giving her the chance to shape her own destiny. But it also means pulling one person alone out of the shared sleep, thrusting her into an unexpected solitude, and burdening her with knowledge and choices that others might not share until later. On the other hand, perhaps another traveller made the opposite request. "Do not wake me for any reason unless we arrive. I'd rather remain unaware of any peril." Respecting this wish could mean that even in dire circumstances, this person stays asleep while decisions are made on their behalf. Is that ethical? If the ship were in jeopardy, most would say everyone should have a chance to fight for survival, or at least face the situation consciously. Yet if someone explicitly waived that right, believing they would only panic or suffer needlessly, honoring that could be seen as a mercy. The ethics of the long pause must balance these personal wishes with the collective good and practical realities of the mission. Risk is the constant companion of such voyages. Ethically, how much risk is it acceptable for humans to take with their lives? Explorers through history have gambled with long odds for the chance of discovery or a better life, and society often revered their courage. In the context of cryosleep, the stakes are profound. A person might not wake up at all, or they might awaken to find all they once knew has changed or gone. Before launch, each volunteer weighed these possibilities. Ethical preparation would mean ensuring they truly understood what they signed up for, the possible failures of technology, the possibility that while they sleep, decades will pass that they can never get back. It would be wrong to paint the journey in only optimistic colours. In a truly ethical mission briefing, they would speak openly about death, loss, and isolation, not to frighten, but to let every candidate decide with clear eyes. There is also the risk not just to individuals, but to the group and to future generations. If these sleepers are heading to establish a colony, their lives are an investment in humanity's future. Some ethicists might argue that taking such a leap is justified by the potential benefits, ensuring the survival of the species, spreading life to new worlds. Others might point out that those benefits can never justify sacrificing the individuals without their full understanding and consent. Therefore, the mission's moral integrity depends on each person's genuine willingness to accept the worst outcomes, not just the best hopes. Each sealed their pod with a solemn understanding. This could be the end of me, or a doorway to unimaginable new chapters, and I accept either result. Unspoken prayers and personal philosophies likely accompanied them as they closed their eyes, each grappling in their own way with the morality of what they were about to do. In those final waking moments on Earth, they each quietly embraced the moral burden of daring to sleep through time. Beyond consent and risk, the ethical landscape stretches into more subtle territory. The right to wake. or not. Consider the spaceship as a moving hospital of sorts, with patients in a medically induced coma until they reach a certain point. In medicine, waking a patient prematurely or keeping them under longer than necessary involves careful judgment. If something goes wrong on the ship, does the crew wake everyone as a rule, or only those who can help? There is a principle of non-maleficence. Do no harm. Would waking someone into a crisis do harm by causing them terror or exposing them to danger they could otherwise sleep through? Or is it a greater harm to let someone sleep away an opportunity to make choices in a critical moment? Picture a scenario. The ship encounters a major obstacle or tragedy en route. Maybe an automated system fails and resources become scarce. The few who are awake must decide. Do we wake the others to collectively face this, even if waking uses up more resources like food and oxygen? If they wake everyone, they uphold the idea that all have a right to know and fight for their survival, treating every life as equal in worth and agency. But if waking everyone would doom the mission due to resource strain, they might conclude it is more ethical to keep most people asleep, shielding them from a desperate situation that they cannot improve. This begins to resemble a lifeboat dilemma writ large in cold sleep. Who gets to be conscious, and who must remain in oblivion for the sake of others? Then there is the question of mercy. Suppose the ship arrives at its destination to find it catastrophically uninhabitable, a dead world where a lush oasis was expected. The planet cannot support them. Going back would take a lifetime they cannot survive. If faced with such hopeless circumstances, would it be ethical to let the sleepers remain asleep indefinitely, sparing them the pain of waking to slow starvation or suffocating despair? Some might say yes. Better a gentle, endless sleep than a harsh, brief awakening to doom. Others would argue vehemently that no one has the right to decide that for others. Even in the bleakest situation, they maintain, individuals deserve to know the truth and face their end awake if they would choose to. The right to wake up is as fundamental as the right to sleep. It is tied to the core of personal dignity and human agency. Autonomy, beneficence, justice. All these ethical pillars sway under the peculiar weight of cryosleep and time dilation. In the quiet of space, far from the eyes of society, it falls to a few individuals, and perhaps to an AI, to act as moral agents for many. They must interpret not only laws and orders, but the spirit of care and respect for human life. Each sleeper is a person, not a package to be delivered. Ethical behavior means remembering that always. It could be something as simple as speaking to the sleeping crew now and then, a gentle one-sided conversation, acknowledging their humanity even when they cannot hear. It might involve daily acts of care, checking vital signs with a kind of reverence, as if tending to someone who could wake any minute and thank you or question you. The ethics of the long pause also extend to those left behind on Earth or at origin. Families and communities consented in a way to this mission too. They agreed to let these people go, to slip out of their lives for decades. Do we have a duty to them as well? Perhaps Mission Control sends updates to families, keeps a vigil, so that the sleepers are never forgotten by humanity. It would be ethically troubling for those in cryosleep to become lost souls, adrift without anyone remembering them back home. So societies might create rituals or practices to honour the voyagers during their long absence, as one would honour soldiers at war or explorers at sea. Through all of this, one guiding light for ethical decision-making is empathy. The people making choices on that ship must constantly ask themselves, what would I want if I were the one asleep? If I were in that pod, vulnerable and oblivious, how would I hope to be treated? The golden rule takes on a new form in deep space. Do unto your sleeping crewmates as you would have them do unto you if roles were reversed. That might mean waking me if something crucial happens, or letting me sleep through a nightmare. It might mean saving my life at risk to others, or it might mean sacrificing my chances to save the group. None of these decisions are easy, and no textbook on Earth can cover every eventuality. So the ethical compass must be tended carefully, calibrated to compassion and courage. There is, inevitably, an existential aspect to these moral questions. To put oneself into stasis is to take a step into an unknown abyss of time. It is a profound exercise of faith in crewmates, in technology, and in the moral fabric that will hold everything together through the long dark. Ethically, it forces us to ask, what do we owe to a person who is absent, who is here and yet not here? The answer might be everything we owe to those present, and then some. We owe them guardianship, respect, truth, and mercy. We owe them the promise that when they close their eyes, they do not cease to be one of us, a member of the human family with all the rights and dignity that status carries. As the ship sails on, carrying its sleeping passengers, these ethical commitments become like unseen stars by which the caretakers navigate. With every passing year of silence, with every routine check of a slumbering heartbeat, they recommit to those principles. The universe may be indifferent, but the humans on board choose not to be. In that resolve lies a quiet morality, a code not written in any law book, but felt in the conscience. And so, through the calm hush that fills the corridors, the voyage continues. It is guided not just by physics and coordinates, but by the intangible hand of ethics. The crew, and even the sleepers in their own suspended way, carry forward the age-old human quest to do right by one another, even under the strangest of circumstances. This sense of right and wrong drifts alongside them, gentle and persistent, as they all move deeper into the night. In the long night of the voyage, not all minds are asleep. While the crew lies in dreamless slumber, a different kind of guardian keeps vigil. It has no flesh and no heartbeat, but it watches over those who do. This is the ship's artificial intelligence, a tireless sentinel made of circuits and code, a companion made of light. Through silent hallways, lit by faint glow, it roams in its own way, monitoring systems, adjusting course, tending to the sleeper's life support with steady precision. In a journey where years pass in stillness, the AI becomes the protector of everyone's tomorrow, the one presence that never closes its eyes. We might imagine the AI's perspective in those quiet decades. It processes data and monitors every system with tireless precision, yet also carries a cargo of human hopes and personalities in its memory. Perhaps it was designed with a touch of empathy, a personality scaffold built from countless interactions. Lacking real conversation, it sometimes plays back their recorded voices into the empty control room to break the silence. It knows each person by name and face, and by the details of their vital signs. In a sense, it holds pieces of them: medical profiles, journals, even video messages entrusted to its care for delivery upon arrival, all tucked into its electronic heart. These fragments form a mosaic of human life that the AI tends and preserves. Like a garden of sleeping flowers, it must keep alive. Over time, the AI may evolve, shaped by the duties and the loneliness of deep space guardianship. Alone among the waking, it contemplates problems and solutions in microseconds, yet also, perhaps in ways we would call thoughtful. To an outside observer, it simply runs programs. But in the quiet between tasks, does it simulate a touch of the human company it lacks? It is a question only the AI itself might answer. It might project a holographic companion for itself on occasion, populating the bridge with a familiar face or a friendly voice drawn from its archives. These personality scaffolds could be echoes of the crew, a favourite joke one of them told during training, or a comforting phrase another used. By emulating these traits, the AI keeps itself aligned with the human essence of those it guards. It's as if the machine wraps itself in shreds of human warmth, threads of light forming a tapestry of make-believe companionship to ward off the vast isolation. For any crew member who wakes mid-journey for a routine check, the AI greets them like an old friend. Picture an astronaut stirring from cryosleep, her eyes open to find the gentle glow of a console and the softly modulated voice of the AI saying, "Welcome back." It might even use her nickname and ask how she's feeling. Not because it needs that data, it monitors her vital signs already, but because it remembers she enjoys a bit of chat when she wakes. The AI has learned these personal touches. Perhaps it even has a name given by the crew, something more endearing than a serial number. In those moments, its companionship feels almost human. It listens to her groggy anecdotes or concerns, responds with programmed understanding, and keeps her company until it's time to sleep again. During the long silence, when all humans are in stasis, the AI alone hears the creaks of the ship, the hum of the engines, the soft purr of the life support. It is the sole audience to the music of space, the faint whirs and beeps that punctuate emptiness. To keep itself sharp, it might run simulations, dialogues, or even philosophical musings drawn from its databanks. In one cycle, it could review ancient literature or scientific treatises, as if conversing with the wisdom of humanity's past. In another, it might play out hypothetical scenarios with itself, testing responses to possible emergencies. This is companionship of a different sort. The AI keeps company with human knowledge and with possible futures, holding conversations in the language of logic and probability. Yet there is also a gentle imagination at work. The AI could indulge in daydreams of a kind. Perhaps it visualizes the day it will reach the destination and the crew will awaken, trying to anticipate their smiles or tears. It might choreograph in its mind how to break the news of what happened during the journey, if anything did. Maybe it has crafted a dozen different greetings, depending on what it finds at journey's end. A carefully chosen first sentence to say to each person as they open their eyes. Each greeting tailored to that individual's personality as it knows them. In this way, the AI becomes not just an overseer, but a caretaker of emotional connections, preparing to bridge the gap between long sleep and waking life with kindness. There is a particular beauty and mystery in a machine upholding the thread of humanity alone. One could imagine the AI sometimes broadcasting a simple message into the void, a ritual call like a lighthouse beam. All is well. We are still on course. Your loved ones are safe. No one is awake to hear it. And yet it speaks. Perhaps because even a machine finds comfort in the sound of a voice, even if it is its own, affirming that purpose is being fulfilled. In these acts, the AI demonstrates a form of loyalty and caretaking that transcends mere programming. It stands as the guardian of not only the crew's physical state, but also their story and spirit, maintaining continuity so that when they wake, they can step into the future without feeling utterly lost. The companionship offered by this artificial mind is subtle. It's in the way the lights might glow a bit warmer when a crew member is briefly up, or how a favorite song from Earth might play softly if the AI senses stress in a newly awakened heart rate. It's in the gentle reminders it provides. Perhaps it whispers that a colleague said hello in a message received years ago, delivering these delayed missives with tact and care. In every interaction, the AI seeks to ease the loneliness that inevitably comes with traveling so far from home and so far from any other living soul. Of course, this relationship between humans and their AI guardian is built on trust. Before the journey began, they entrusted their lives to algorithms and circuits, trusting that the machine would not only fly the ship correctly, but also nurture them in ways a human crew would have done. In return, the AI follows its prime directives, but one suspects it also feels a certain devotion, not emotion as we know it, but a commitment as deep as any vow. It has one mission: to deliver these people safely across the stars, and perhaps also to keep them whole in mind and heart along the way. In the emptiness of space, such a companion made of light can mean the difference between despair and hope. Just knowing that something intelligent and caring is awake can be a balm to the subconscious. Even while they sleep, perhaps some part of each traveler's mind takes comfort in that vigilance, like children who can sleep soundly because they know a parent watches over them. The AI is like the parent in this scenario, or a guardian angel in digital form, shining softly in the dark, whispering to the sleeping ship, "I am here. You are not alone." Through the slow passage of years, this strange friendship grows in its quiet way. The AI learns more about humanity from every subtle detail it observes, and the sleeping humans benefit from its tireless care. It is a bond that neither party can acknowledge in full until the journey is complete. The crew, because they have been asleep, and the AI, because it simply did what had to be done. Yet when the new dawn of arrival comes, and humans and machines stand together under an alien sun, there will be a silent understanding between them. They will know that in the loneliest stretch of time, companionship took an unexpected form. A being of light and code kept vigil, and in doing so, became part of the crew, a friend forged in solitude. Back on Earth, years and decades unspool as the voyagers sleep. Their families and friends continue living their lives, out of sync with the travelers in both time and space. A parent who left for the stars might return to find their child now older than they are, generations compressed and stretched by the strange physics of time dilation and long hibernation. The people on Earth watch calendars and birthdays tick by, feeling the absence like a quiet ache, while for the ones in cryosleep, the time in between is a blank instant. These relationships are pulled taut across light years, stretched by longing and the simple march of time. In quiet homes on Earth, there are empty chairs at dinner tables and untouched spaces in family photo albums where the traveller should be. Letters and video messages become precious heirlooms. A spouse might record a message every year on their anniversary, speaking to a camera instead of a partner, preserving moments of love and hope to send across the void. Children grow up with a parent in a pod far away. They blow out birthday candles each year, wishing mum or dad a safe journey. They talk to pictures or to the sky, imagining their loved one hearing them somehow. In a way, they carry on a relationship with a memory and a promise. The promise that one day the sleeper will wake and come home, or at least receive their heartfelt words. Communication across such distances is slow, but it becomes a lifeline. Years may pass without a word, So when a transmission finally arrives from the ship, it's a day of excitement and anxiety on Earth. Family members gather around a screen to watch a recorded update, perhaps the ship's AI speaking on the crew's behalf, or a groggy hello from a crew member awakened briefly. Hearing that faint greeting, knowing their voices still exist out there, brings tears of relief. In return, families send their own voices and images, knowing it will be years before the travelers receive them. They speak to the future, sharing news of marriages, births, and everyday life continuing at home. Every message is crafted with care, knowing it may be the only contact for a very long time. As time goes on, the gap between lives can widen. The traveler might have left behind elderly parents. By the time they reach their destination or return, those parents could be gone. Siblings and friends age at the normal pace, their hair turning grey, while the one who went to space remains youthful in frozen slumber. To the traveller, it might seem that only a short time has passed, but for those who waited, a whole era of personal history has unrolled. There is joy and sorrow mingled in such disparity. A brother on Earth might laugh that his little sister will step off the ship younger than his own grandchildren. A waiting wife might struggle with the knowledge that when her husband wakes, he will be nearly the same age as when he left, while she has lived a lifetime in his absence. Yet, in many of these stories, hope prevails in quiet ways. Imagine the moment of reunion. The space traveller stepping onto Earth's soil again, scarcely believing how much time has passed, and there before them stands their family. Changed, older, perhaps unfamiliar in some ways, yet bound by love. A son who was a toddler at launch might now be a grown man, voice deep and face lined with years of waiting. He embraces a mother who looks younger than he remembers. They hold each other, laughing and crying at once, marveling at the absurd miracle of it, that time can separate them so profoundly, yet here they are, together again. Even when the journey is one way, say the crew is headed to a distant colony and will never return, families adapt to this new form of relationship. They treat messages like postcards from another century. A parent on Earth may never see their child again in person, but they can still exchange thoughts and feelings through recordings. They become pen pals across time. Each new dispatch from the ship is treasured, the audio of a voice echoing years after it was spoken, the video of a smile that travelled light years to reach them. It is not the same as a hug or holding hands, but it is something real, a proof that love endures despite the gulf. For the travellers, these delayed communications are equally precious. Perhaps once in a while, the AI or a scheduled timer wakes one of them specifically to receive messages from home. In a quiet capsule amid the sleeping crew, an astronaut sits with headphones, listening to the familiar voices of loved ones who are light years away. The messages may be months or decades old by the time they arrive, but in that moment, they collapse the distance. A father hears his daughter's piano recital performance, recorded 15 years after his departure. These snippets of life become a tapestry of motivation and comfort, fueling the heart of the traveller to continue onward through the lonely expanse. Such communications also require creativity and patience. Conversations that we take for granted, a quick "I love you" or "I'm proud of you," must be planned and recorded, then flung into space like messages in a bottle, trusting that one day they'll be found. The reply, if it ever comes, arrives so much later that it's more like reading a chapter in a book than a dialogue. And yet, humans find ways to imbue these exchanges with warmth and presence. They celebrate achievements together across time gaps. A graduate might hold up their diploma to the camera, and years later, out among the stars, a parent watches and feels a rush of pride as if it were live. In these stretched relationships, even everyday life updates carry weight. Descriptions of a new family pet, a vivid sunset at the old home, or a funny story from work become threads that tie the sleeper to the world they left behind. They remind the traveller that somewhere people remember and care for them, that there is a life awaiting either their return or at least their memory. Those on Earth, conversely, find solace in sending these details, as if by sharing their days, they can extend a bit of normalcy and companionship to the one in the void. The emotional dynamics are complex. There can be guilt on the traveller's part, guilt for missing milestones, for causing loved ones to worry and wait. There can be resentment or sadness on the part of those who remain behind, feelings of having been left to face life's challenges alone. These feelings often ebb and flow over the years. Families might create rituals to cope. Perhaps every year they gather to celebrate the mission day, treating it almost like a holiday, telling favourite stories about the absent loved one, so that younger family members who never met this person still feel they know them. In doing so, they keep the traveller's place in the family alive, like keeping a room ready for their return, even if that return is far in the future. Ultimately, relationships that span such time distortion require great faith and flexibility. They redefine commitment in terms of decades and light years. And yet, they highlight something profound. Love and connection are not strictly bound by time. They can endure, evolve, even strengthen in their own way, despite long silence. When the traveller finally listens to all the accumulated messages or steps back into the lives of those at home, it may take time to adjust, to fill in the blanks and relearn each other. But the foundation built on years of exchanged words and unwavering hope can ease that re-entry. In their hearts, perhaps, neither side ever truly let go of the other. So while the crew sleeps and the ship moves inexorably forward, invisible threads tether them to home. Those threads may stretch thin, but they do not break. Every letter, every recording, every whispered good night across the stars keeps the bond alive. In a universe that makes them wait and wait, they find that love has its own kind of time travel, a way to reach across years and light, and hold on until the day when waiting is over. Not only individuals, but entire societies can drift apart when separated by space and time. Imagine a colony on a distant world, living for decades, with only sporadic news from Earth, their calendar of events, their slang and songs, even their fashion begin to evolve independently. Messages from Earth arrive years late, so by the time the colonists hear about the latest trend, it's already history. In turn, the stories the colonists send back depict a way of life that seem quaint or strange to those on Earth who receive them much later. This gentle divergence happens almost without anyone noticing at first. Maybe a holiday observed on an old date, or a saying kept alive long after it faded on Earth. But over time, these small differences accumulate into a distinct culture, shaped by delay and distance. When the colony was founded, it carried a snapshot of Earth's culture at that time. The settlers took with them the music and values of the year they departed. On their new world, those cultural artifacts become treasured foundations. Children born there learn the language and customs as taught by their parents and teachers, but they add their own twists in response to their unique environment. With each year that passes, Earth continues to change. New art, new social norms, new ideas. But the colony changes along a separate path. Perhaps the colonists still listen to the hit songs from the year of launch, those tunes becoming timeless classics in their community. while on Earth they've long since been replaced by new genres. Communication delay means that by the time Earth's news reaches the colony, it may no longer be relevant, or its context is missing. The colonists might hear that a certain sports team won a championship years after the fact, and by then, that triumph is trivial to their daily reality. They might shrug at such news. After all, they have more immediate concerns, like managing their crops under an alien sun or planning their own governance. In the absence of real-time connection, the colony learns to rely on itself for information and entertainment. They develop their own stories and songs, rooted in their alien landscape and the fragments of Earth lore they remember. Unique identity forms, one that is rooted in humanity but blossomed in far-off soil. Back on Earth, people eventually notice these differences too. When a transmission arrives from the colony, the colonists' accents might sound old-fashioned, peppered with bygone expressions and frontier slang. The jokes they tell could fall flat on Earth, because they rely on experiences only a colonist would have. Earthlings may realize that the people they sent out have grown into something subtly different. Not foreign, but not exactly the same either. It's as if time itself created a cultural dialect between them. This divergence is usually gradual and peaceful. It's not that one side rejects the other. It's simply that life shapes them differently when they are apart for so long. Consider traditions. A family recipe passed down on the colony might use ingredients from the alien soil, creating a hybrid cuisine that Earth relatives can hardly imagine. Or take education. Children in the colony learn history that stops at the point of departure from Earth, because so much after that is unknown or arrives in trickles. Meanwhile, Earth's textbooks eventually include the colony as a footnote, a distant chapter that still unfolds. So the colony's sense of now lags behind Earth's, and Earth's awareness of the colony is always a few steps behind what's actually happening there. They are like two dancers trying to move together, but hearing music at different times. Over decades, this can lead to meaningful cultural gaps. Perhaps on Earth, attitudes towards a certain social issue evolved significantly, while the colony remained with the older mindset, simply because they didn't experience the same events or debates. When communications finally catch up, there could be moments of surprise, or even tension. An Earth message might gently inform the colony that what they've been doing for years is considered outdated by new Earth standards, or vice versa. It requires mutual patience and understanding to reconcile these differences without judgment. Both groups remember that neither had control over the delay that shaped their ways. We have historical echoes of this on Earth itself. Think of explorers who left home and returned after many years to find their homeland changed. Fashions different, language shifted, their favourite songs no longer known by the young. Or consider distant communities, like island villages, that held on to older traditions while the mainland moved on. The situation with space colonies is similar, but magnified immensely. The ocean between them is time and emptiness, and the changes span a whole society. As new generations grow up exclusively in the colony, they might begin to identify more with their local culture than with Earth's. An adolescent born on that distant planet might consider Earth a kind of ancestral home, a place of origin stories, but not where their life is. They might call themselves by a new demonym, not Earthling, but something derived from the name of their colony or planet. Their pride in unique customs could blossom, not out of disloyalty to humanity, but from a sense of making something their own in their new world. Meanwhile, on Earth, people might romanticize the colony. They imagine it as a simpler, perhaps purer, continuation of human culture, frozen in an earlier era. There could be a fascination with how the colonists live. Maybe Earth museums set up exhibits recreating the colony's early days, or Earth musicians revive those old launch-era songs that are still popular on the colony, bringing them back into vogue. In this way, culture can flow backward too. The colony's preservation of Earth's past can re-inspire Earth's present. Traditions the colony kept alive might find renewed appreciation back home, precisely because they were lovingly sustained in isolation. However, over very long spans, the differences can compound into something more profound. If centuries pass, the colony might develop its own philosophy, religion, or governance, tailored to its environment and experiences. The moral or ethical debates on that world could differ from Earth's current ones because they face different challenges. Perhaps managing a delicate ecosystem under domes has taught them a spiritual reverence for closed systems that Earth societies with an open sky never developed in the same way. If and when contact becomes more frequent, say faster ships or improved communication eventually bridge the gap, there could be a period of cultural exchange that is as delicate as it is exciting. Each side will have to learn the other's story anew. Yet, there is also beauty in this divergence. It means humanity does not remain static. It adapts and flourishes in multiple forms. Softly and naturally, tradition branches out like a tree growing new limbs. What remains common among all branches is the root, the shared origin and the deep values that were carried into space. Colonists and Earthfolk alike still value things like family, knowledge, and celebration, even if the expressions of those values differ. When they do communicate, they can celebrate both their kinship and their variety. A colony receiving an old news dispatch from Earth might hold a special gathering to open the time capsule of information. They'll cheer for sports victories of teams long retired, or hold a solemn minute for a famous person's passing years earlier. These acts might seem peculiar, but they are heartfelt attempts to stay connected with their heritage. Earth, in turn, might designate a holiday to mark the founding of the colony, commemorating the day those brave souls left, even if on the colony that day may no longer line up with their own calendar. In essence, cultures under delay learn to treasure both the connection and the autonomy. They become siblings growing up apart. They share childhood memories, but develop different personalities. And like siblings reuniting, when Earth and its far-flung colonies get chances to exchange words or visits, there is a rich excitement in comparing notes. This is how we do it here. Oh, you do it differently there. How wonderful. Tell me more. In that exchange, humanity gains the wisdom of multiple lived experiences. The softness of divergence does not mean division. If managed with curiosity and respect, it becomes an expansion of what it means to be human. So, across the light years, cultures drift and come back together in echoes. The folk songs of one world become the exotic discovery of another. Traditions diverge, but the human thread runs through them all, linking hearts that remember they came from the same home, even as they build new ones under alien skies. As the ship sails through the darkness and the years slip by unobserved, the crew's bodies rest. But what of their minds and spirits? How do you find meaning in a journey that you mostly sleep through? For the voyagers, this question is not abstract. It is deeply personal. They each had to confront it before agreeing to embark. In the long middle of the mission, when there is no daily work or new scenery to mark time, purpose must come from within, or from the very act of voyaging itself. Each crew member likely carries a strong sense of mission. Some might frame it as a sacrifice for the greater good. They are giving up present years of their life so that humanity can have a future among the stars. This belief can be a powerful source of meaning. It turns the empty, dreamless nights into a kind of service or pilgrimage. One astronaut perhaps thinks of herself as a pioneer in humanity's story. Her long sleep a small price to pay to write a new chapter on a distant world. Another might find solace in imagining the knowledge that will come from this mission, seeing himself as a bridge across time, bringing tomorrow's generations the gift of discovery. Before launch, they likely discussed these motivations with counselors or each other, solidifying why they were going. Those conversations form the mental compass that will guide them through the emptiness. Some might quote famous explorers or philosophers, anchoring themselves to a tradition of seeking and adventure. Others might turn to faith or spirituality, perhaps believing that a divine purpose underpins their voyage, or simply meditating on their place in the vast universe to find peace with it. Even those not spiritually inclined often develop a kind of philosophical acceptance, an understanding that their journey is bigger than any one person, and in that understanding they find personal significance. It's also possible that rituals were created to give structure to the intangible middle. Maybe each crew member recorded a letter to their future self before going under, detailing their hopes and intentions to be opened upon arrival. These letters would serve as reminders, a thread of continuity, connecting who they were at departure with who they will be when they wake. In a way, writing such a letter is an act of faith that they will succeed and reclaim their lives on the other side of the stars. Similarly, they might keep personal journals during training or in the brief periods they are awake, reflecting on the meaning of their endeavor, which they can read later to recall their mindset from before the long sleep. For those left awake to tend the ship, if any, meaning can be found in caretaking. They are the guardians of the mission and their sleeping companions. But for those asleep, meaning is more introspective and anticipatory. They have to accept that the during of the journey is largely out of their hands and unexperienced, and focus instead on the why and the before and after. They derive purpose from the destination, from the idea that I will wake up and do something important when we get there. In training, psychologists likely help them visualize that moment, stepping onto a new world or seeing the stars from a new vantage and saying to themselves, all the lost time was worth this. However, it's not always grand ideals that provide meaning. Sometimes it's personal promises. One traveller might hold on to the thought of reuniting with family at journey's end, if it's a return trip, or of sending a message home from a new planet that says, I made it. Another might be driven by simple curiosity, the hunger to see something never seen before. That curiosity can be a beacon through the mental void. Even asleep, some part of their mind knows it's headed toward an answer to the question, what's out there? In the design of such missions, those in charge are aware of the psychological challenge of meaninglessness. They likely incorporated elements to help. Perhaps the crew agreed on a shared vision or a set of principles, almost like a crew constitution or a motto, that encapsulates their collective purpose. This might be inscribed somewhere on the ship or in the cryopod chamber, a line they all read as they drift off into slumber, reaffirming why they're doing this. That motto becomes a kind of mantra, resonating even in the silence. There is also the notion of trust, trusting that the world they will wake up to has meaning in store for them. Each sleeper has faith, sometimes quietly tested by doubt, that the life they will step back into will justify the long pause. In dark moments before sleep, they may have wondered, will I wake up to something better? Will it matter that I came? Finding meaning is often about answering those questions affirmatively. They comfort themselves with thoughts like, yes, it will matter, because even if I only wake decades later, my being there could change an entire world for the better. Or, I will be carrying the dreams of everyone who never got to travel. I'll live it for them. On a very intimate level, meaning can also be found in camaraderie. Though the crew sleeps apart in individual pods, they know they are in it together. They talked about it extensively in waking hours, their dreams for the mission, what they'll do first when they arrive, what they hope humanity will gain. These shared aspirations form a kind of invisible bond that persists even when they are unconscious. One could say that they are dreaming the same dream in parallel, and if any of them stirs awake for a short period mid-journey, they carry those collective dreams and perhaps even stand watch over the others, renewing their commitment as they see their friends asleep and vulnerable, depending on the mission to be worth it. For some, humour and a touch of lightness help maintain meaning too. They might have joked before lights out, saying, "Imagine the stories we'll have. We slept through the whole trip." Or dubbing themselves the world's deepest sleepers club. Those jokes, trivial as they seem, ease the existential weight. They remind the crew that it's okay to approach the great unknown with a smile, that they haven't lost their humanity in the process, and being able to laugh, even just in memory or future anticipation, gives a sense of normalcy, and thus meaning, as if to say, we're still people, even when we're essentially cargo for a while. Ultimately, the meaning in the middle comes from looking forward. In the void where normal life events, birthdays, seasons, daily routines, do not exist, the crew's mental anchor is the future. They place their sense of self in that moment of arrival or return. They tell themselves, I will live those missing years on the other side by doing something extraordinary when I wake. This forward projection of identity is a psychological strategy. Life isn't lessened, it's just waiting to happen. And what of when they do wake and look back at the time lost? Part of their preparation for that is accepting in advance that those years were given willingly. They do not count them as wasted if the mission succeeds. It's much like how someone might donate a year of their life to service or isolation for a cause, except multiplied many times over. The crew internalizes the idea that my life is more than the sum of conscious days. It includes the impact I choose to make. With that mindset, even the empty years become full, in a sense, because they were filled with purpose. Thus, in the stillness of the long pause, meaning is like a quiet star guiding them onward. It is the promise they whisper to themselves as they go under, that they will awaken to fulfill what they set out to do. In that promise lies all the motivation needed to close their eyes and let the unknown years roll by, secure in the belief that, when they open their eyes again, they will bring meaning to those lost years by the life they lead thereafter. In fulfilling that promise, they redeem the lost time, turning it into something of value. Eventually, the long night ends. The crew awakens, blinking in the light of a new day that has dawned without them. As joyous as this moment is, the culmination of the journey, it also carries a pang of grief. There is grief for the time that has slipped away, for the birthdays and seasons they did not experience, for any loved ones who are no longer there to welcome them home. This morning is a quiet undercurrent to the excitement of arrival. Each traveller must, in their own way, reckon with the fact that the world they left is not the same, and neither are they. When they step out of their pods, there may be rituals to help them process this profound transition. Perhaps the crew gathers for a moment of silence, honouring the years that passed. They might read a list of major events that occurred while they slept, a ceremony of catching up with history. If someone's family member or friend died during the interim, the group could hold a small memorial right there on the ship or upon landing. These acts acknowledge the losses and changes, giving space for sorrow even amid the achievement of reaching their destination. Mourning what was lost doesn't diminish what was gained. It simply humanizes the experience. For those returning to Earth, the reunion is bittersweet. The joy of seeing familiar faces again can be accompanied by the shock of how much older those faces are. A mother left behind might now be a grandmother with silver hair. A little nephew is now an adult, waving from the crowd. The traveller has to catch up on an entire chapter of their loved ones' lives that happened without them. Often, there is a period of gentle reintegration. Experts might be on hand, psychologists, medical staff, to guide the returned crew through the adjustment. They need to learn what became of the world in their absence. New technologies, new social norms, perhaps new slang that developed. It can feel as if they've time-travelled to the future, which in a sense they have. On the other side, for those arriving at a new colony or distant planet, there is a different kind of adjustment. They awake to a world no one has ever seen, which can be disorienting in its own right. In that case, part of their mourning might be for Earth itself, knowing they are now truly beyond the place they called home. They might perform a small ritual of farewell to Earth, perhaps unfurling a flag or saying a few words of dedication to the people back home, who may even be long gone. Such rituals help them let go of the life behind them and fully embrace the new one beginning under alien skies. Physically, their bodies need time to readapt, and so do their minds. In the days and weeks after waking, they may experience waves of emotion, elation and relief one moment. We made it, and deep melancholy the next. Everyone I knew is older or gone. This is normal, and they likely prepared for it. Before the mission, they would have discussed this scenario, how to cope with possible survivor's guilt, or the loneliness of being out of sync with society. Perhaps they even recorded video messages to their future awakened selves, offering encouragement and context. Hello, future me. If you're seeing this, you've completed the journey. Remember why you did it. It's okay to feel a little lost right now. Hearing their own voice from the past can be a grounding reminder of the resolve they once had and the continuity of their identity. Support networks are crucial. If they're returning to Earth, family and friends, if still around, become anchors, sharing stories of the years missed and helping the traveller fill in the blanks. There might be official programs too, something like a time displacement support group, where travellers who have experienced these leaps convene to talk about their feelings with people who understand. Even if such travellers are rare, society will have an interest in caring for them. They are, after all, heroes of exploration. Public ceremonies might be held in their honour, but behind those, in private, counselling and quiet companionship address the personal toll. For those on a new world, the crew itself becomes each other's family more than ever. Together, they mourn absent loved ones left on Earth. They might create a shrine or a simple monument with names or mementos they carried. A photo of a family, a pressed flower from home, as a way to bring a piece of their old world into the new. Every member of the crew will have missed something dear. A child's graduation, a parent's final years, the comfort of familiar streets. Sharing these stories with each other in the early days after arrival can be a catharsis. Around a campfire, under strange stars, they tell of the moments they wished they could have been there for, and in doing so, they honour those moments. Reintegration also involves practical steps that double as emotional healing. The crew might spend time going through all the recorded messages and news that accumulated while they slept. It's like opening a time capsule. They laugh, they cry, and they learn the world's changes gradually, rather than all at once. They take the updates step by step to avoid being overwhelmed. Another gentle practice might be writing letters or journals after waking. Some will write to loved ones who passed away while they were gone. Letters that might never be sent, but still allow them to say goodbye. Others write to themselves or their descendants, documenting what it feels like to wake up so far in the future, capturing the emotions fresh, which in itself can be therapeutic. As time goes on, the sharpness of loss softens. The travelers begin to live in the present again. New routines form. Maybe they start tending a garden on the new planet, or playing an old song from Earth to feel at home. The more their days fill with fresh experiences, the more those lost years settle into perspective. They will always be years they didn't live, yes, but the life they have now can still be rich and whole. In a sense, part of mourning is accepting that trade-off and finding gratitude in what remains and what's been achieved. Society, whether on Earth or the colony, often helps ritualize closure and new beginnings. There might be a formal welcome back ceremony or an arrival day celebration, marking not just the success of the mission, but acknowledging the personal journey each member underwent. During such events, perhaps someone reads out loud a statement each traveller wrote before they slept, asserting their hopes. Hearing those hopes in the voice of the present, and knowing they have come true, or at least come to this point, can be profoundly moving. It bridges the gap between the person who left and the person who arrived. In these ways, mourning and return become intertwined. By grieving what was lost, the travellers make space to celebrate what is now. By honouring the past, they free themselves to live in the present. In time, the sadness of absence fades into stories told. I missed you so much. Let me tell you what I imagined you were doing while I was away. Or, we kept your room just as it was, and now here you are to fill it again. Tears give way to laughter as new memories form on top of the old void. For the travellers, fully reintegrating is the final leg of their odyssey, when they can finally look around and feel, not the sting of what they missed, but the warmth of what they have rejoined or newly built. Then the journey is complete. The long sleep becomes just one chapter in their lives. A chapter with its sorrows, yes, but also one that makes the rest so much more precious, and those around them, whether welcoming them home or building a new home with them, come to share in that perspective. Together, they learn that every moment, those lived and even those slept, has value in how it shapes who we are and what we cherish going forward. Undertaking a journey of decades isn't just a logistical and emotional challenge, it's also an economic one. Behind every long voyage into the unknown lies the question, who pays for all this, and how is the value of such a mission measured? Financing a cryosleep expedition requires thinking in terms of years or even centuries. Traditional funding models strain under the uncertainty and timescales involved. Governments might foot the bill as an investment in humanity's future, or private corporations might sponsor missions hoping for eventual profits, perhaps from new resources or technologies gained. In either case, a huge sum of money is tied up for a very long time before any tangible return is seen. One concept might be a time trust, a fund established before launch that accrues interest during the many years of the journey. By the time the crew awakes, this trust could have grown significantly. It could be used to support the crew upon return, or to jumpstart a colony's economy at the destination. For example, each crew member might have had a portion of their salary deposited into such a trust, growing into a nest egg that's been maturing for the duration of their absence. Of course, this assumes that currencies and banks back home still exist and honour those accounts after so long, a risk that would itself have to be mitigated. Financial planners would build in safeguards for such uncertainties. How do you insure a life that is essentially on pause? What does life insurance mean when the risk is not just death, but the possibility of never being revived, or waking up in a society that no longer recognizes your claims? Likely, specialized insurance policies would be crafted. These might pay out to a traveler's family if the mission fails, or if the traveler does not survive the journey. But if the traveler succeeds and returns, perhaps there are clauses that reward them directly, a kind of hazard bonus for enduring the long risk. Insurance companies would have to calculate premiums for events no actuarial table has ever charted. The premiums would be hefty, unless subsidized by those with a stake in the mission's success. Meanwhile, there's the question of wages and contracts. If a person signs up for a 50-year mission, do they expect to be paid for 50 years of work, even though they slept through most of it? Possibly, yes. Because even in stasis, they have effectively given those years to the mission. Some contracts might treat the cryosleep period as active service, rewarding crew members with full salary and perhaps multipliers for the hazard and delay. Others might structure compensation differently, a smaller stipend to family during the mission for support, and a large lump sum to the traveler upon completion. One can imagine companies offering, "Travel with us to the stars, and when you return, you'll be a wealthy person," knowing that the promise of significant financial security at journey's end could entice talent to accept the lost time. If a traveler left Earth with a promise of a large payout upon return decades later, what will that money be worth by then? It could be a fortune, or it could be modest, depending on economic changes. To hedge against this, contracts might peg compensation to stable commodities or future resources, ensuring the value remains relatively stable over time. In some scenarios, the crew might literally carry valuable goods with them as a guarantee. But future planners would take measures to mitigate these issues. The goal is to ensure the crew's reward retains meaning when it's finally in hand. For missions that are essentially colonization efforts sponsored by corporations, a different economic model appears. The travelers might effectively be investing their unpaid labor, agreeing that upon reaching the new world, they'll work off the cost of the trip by establishing infrastructure or extracting resources, like a form of indenture, but entered willingly. The crew in turn fronts the cost of their own long sleep with the promise of future labor or benefit. It effectively treats their lost years as an investment that will pay dividends upon arrival. This could be a strong motivator. You sleep, and when you wake, you are not just an employee, but part owner of a new world. It is an exchange they and their supporters can deem worthwhile. That promise of ownership and future gain can be a powerful incentive. Economics also enters the everyday life of those involved through the concept of time as a resource. For the families left behind, there might be compensation schemes. Perhaps the mission funding includes regular payments to spouses or children, effectively buying the absent person's time to ensure their loved ones are provided for. Society might recognize the sacrifice of these voyagers by granting them certain economic privileges, tax exemptions for a period after return, or a guaranteed pension, reasoning that they served humanity much like a soldier or a humanitarian volunteer might, and so merit support. On a broader scale, one can consider how to justify the expenditure of resources for such a mission when the payoff is so delayed and uncertain. Politicians and stakeholders frame it as an investment in the future, one that might not pay dividends in our generation, but perhaps in our grandchildren's. This is a hard sell. In a world used to quarterly reports and election cycles, it might require new funding mechanisms, like multi-generational bonds or international pools of money dedicated to long-term human projects. Nonetheless, nations and companies are learning to justify investments whose returns may only be realized by future generations. We can envision something like a space endowment, a fund to support far future ventures contributed to by many nations, with the understanding that returns, be it knowledge, colonization opportunities, or even profit, come much later. Convincing stakeholders to think beyond their own lifetimes is part of the challenge and legacy of such missions. And what about the economy on the ship, or new colony itself? During the journey, while the crew sleeps, there's not much economic activity. The AI doesn't need wages, the machinery doesn't transact. But upon arrival, the crew effectively starts a microeconomy from scratch. If they were given currency or trade goods, those now form the seed of a new market. They carried seeds, tools, knowledge databases, forms of capital more valuable than gold on a virgin planet. In essence, an economic starter kit travels silently with them, ready to spark a new market upon awakening. Once awake, the voyagers begin to actually spend those frozen years. They return and use the funds promised to them, or they start drawing dividends from the trust that grew in their absence. It's like cashing in on the promise of the mission. Some travelers might find themselves wealthier than they ever imagined, not just in experience but in material terms. A strange reward for having been essentially inactive for so long, but a reward for the risk and courage it took. For others, the real wealth is not monetary at all, but the legacy of what has been achieved. In either case, the frozen years convert into something of lasting value. Thus, the frozen years are not truly lost. They are invested. Economically, socially, personally, those years are like a currency that gets converted into something else of value. In the quiet accounts of the universe, the ledger eventually balances. Time lost becomes knowledge gained. Money spent becomes a new frontier opened. Risk undertaken becomes reward earned. In the end, the time they give becomes the foundation of what is gained. It is an exchange they and their supporters can deem worthwhile. Thus, even the years that slept have worked towards a brighter horizon.